Do you want to?
Okay, and if anybody else needs to
Yeah,
speak.
Yeah.
Okay.
Okay, we're set, I think. One person's gonna sign in, then John's gonna kick it off.
Awesome.
Lisa, do you want to introduce John, or? I'll introduce John, and I don't have his bio, so he's going to tell you what he does, but he also, we had never done climate and weather for the Heartwood class until last year. And so for the very first time ever, John helped us out, and he's a professor at Texas A&M, and I think he's also, I hope you talk about CoCoRaHS.
Yeah, I'll be doing that.
Outside, we have a bunch of rain gauges, of which I have one in my house. I'm a CoCoRaHS member. He's going to tell you what that is. Carolyn bought a whole case of them, so you can buy one from Heartwood at a reduced price. And if you become part of the network, that counts for volunteer hours to the tune of 2 hours a month. If you just record zero rain, or at this last rainstorm we came in, I'm in southern Walker County. I got 2.48 inches of rain, which
Wow.
I dutifully recorded. So we got a lot of much needed rain in the forest. So with that, John, are you good?
I think so. Are y'all remotely seeing the slides properly?
Yeah.
Okay, great, thanks.
You can see them on. Carolyn, can you see the slides?
I am seeing the slides. I
All right.
I see the presenter's view so that I see the first slide and the next slide side by side. Is that what you wanted?
Well, you know how it goes. The projector is showing the slides, and this is showing the presenter view, so I don't know how to get it to coordinate.
Well, up at the top, John, up at the top on display settings, I
Yeah.
think if you click that, let's see if it tells you, yeah, swap, duplicate, try duplicate
Like
slideshow.
that.
There, that's it. You got
All
it,
right.
guys. Thank you.
Okay, and then let's
But wait, do we want
get
everybody?
this out of the way.
Yeah.
There we go.
I'll put it over here. Good morning. I'm John Nielsen-Gammon. I'm the Texas State climatologist, and I'm a professor at atmospheric sciences at Texas A&M University. I've been at A&M for a little more than 30 years. I've been a state climatologist for a little more than 20 years, and I've been doing presentations like this for about 20 years also. The job of the state climatologist is to help the state of Texas make the best possible use of weather and climate information. And that includes helping people understand what the heck is going on with the weather and climate. And there's usually something going on because it's Texas. So I'm going to, let's see what we got here. Nope. 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 Hang on a second. There we go. So I'm going to talk about the climate of Texas and how that works. Brief view of rainfall and temperatures, and then talk about how the climate changes, both on the short term, which is mainly through El Nino and La Nina, and then longer term climate change also. I'll go into some of the many facets of extreme weather in the state of Texas, and wrap it up with the fact that not only can we just talk about the weather, but we can also do something about it through the CoCoRaHS rain gauge network. And as I go along, please interrupt me for questions. You want me to talk about something or explain something in more detail, I'll be happy to do so. And the reason weather and climate is part of a master naturalist program is because ecosystems are the way they are because of weather and climate. The basic aspects of rainfall, for example, are what distinguish West Texas environment from East Texas environment in fairly obvious ways. Temperature matters also. Particularly, you can see that as you go from north to south across the state of Texas. And it's not just the average conditions that matter, because for the most part, the range of a particular species, whether it's plant or animal, is going to depend upon whether it can tolerate the extremes of the climate. How cold does it get during the wintertime? How hot does it get during the summertime? How long can you go without rainfall? And all of those are aspects of climate. Climate by itself basically refers to the statistics of the weather. So it's the average conditions, it's the range of conditions, and it's the bounds of the extreme conditions. And Texas is a somewhat challenging environment. It gets extremes in all sorts of directions, like plants that need to be drought tolerant. We get droughts throughout the state. They have to be aridity tolerant in West Texas. We get heat in the summertime. Temperatures are typically in the 90s or 100s throughout the state of Texas, except for maybe the very high elevations in West Texas. And we get cold temperatures in the wintertime. Original version of this slide referred to cold in the north, but as we saw last year, you can get cold temperatures just about everywhere. Let's see. Now, if the Earth were just a ball of land with no topography or what have you, climate would only vary from north to south. There'd be nothing to distinguish one particular longitude from another longitude. The north to south variations would be because the sunlight is unevenly distributed over the Earth. It's shining directly at low latitudes near the equator, and it's just sort of giving a glancing blow to high latitudes. So we would get north-south variations in temperature. We would also get weather because those north-south variations are large enough that they make the wind patterns unstable, and so we get storm systems developing in response to that. But in our real Earth, we've got climates that are different from one place to another. For example, our climate is different from the climate in Southern California, which is different from the climate in, say, Eastern China. And all of those places are at the same latitude. But the reason the weather comes out different is because of the distribution of the oceans and the land and the mountains and so forth. So here in our setting, there are three main factors geographically that determine our climate. First off, we've got land to the north. So if you drive north from Texas, of course you make it Oklahoma, Kansas, Nebraska, eventually you get to Canada, and you've got another whole country again before you make it to the Arctic Ocean. Land tends to have a very variable climate. Temperatures have fairly large swings. So when we get weather from the north, that's air that's been over land a long time. Humidity tends to be low. Temperatures tend to be lower also. To the south, we have the Gulf of Mexico, which is our main source of moisture. So when the winds are from the south, the air tends to be fairly humid, like it is today, for example. And furthermore, the temperatures tend to be fairly moderate. Oceans absorb a lot of heat. They distribute it through substantial amount of water mass, so that basically the top 100 to 200 feet or so of the Gulf of Mexico is going to have basically the same temperature as the very surface of the water. That doesn't happen over land. Land is not turbulent. Your temperatures or changes are confined to the very top layer of land. You go down 10 feet or so, it's hard to actually tell the difference between summertime and wintertime because the the temperatures are pretty much insulated by the land above it. So summer and winter, land surface temperatures change a lot, ocean not so much. And so temperatures are moderated when we have winds from the south. And then the third aspect is the topography to our west. The Rocky Mountains, Sierra Madre ranges in northern Mexico, they do two things for our climate that are very important. First thing is they block any moisture that comes from the Pacific Ocean. Anything coming from the Pacific has to rise up over the mountains, and that tends to wring out a lot of the moisture along the Pacific coast, and the air is relatively dry when it makes it to us. Secondly, it basically forms a barrier to air in the sense of we very rarely get winds from the west in much of Texas because air from the west is going over the mountains and tends to be at higher altitudes over Texas. We get winds from the south, from the Gulf of Mexico, and from the north, channeled along the Rocky Mountains, and sometimes from the east, but except in far west Texas and some of these mountain gaps, you don't get a lot of wind from the west. And so that means, for the sake of moisture in Texas, it's pretty hard to get a lot of moisture in West Texas, particularly when the predominant flow direction is from the south or north. You know, you only have half of Texas where the Gulf of Mexico is to the south. The other half of Texas, you got mountains to the south. And so that gives us the big range in conditions from west to east across Texas. East Texas gets moisture throughout the year, West Texas not so much. So the annual rainfall distribution in Texas pretty much is a west to east variation. You get less than 10 inches of rain around El Paso, whereas the extreme southeast quarter around Beaumont, typical rainfall in a year is about 60 inches. Where we are, it's around 45 to 50 inches a year. Now, so that's annual conditions. Obviously, temperatures vary a lot from winter to summer, but rainfall and precipitation do also. The variation from west to east is even more extreme in the wintertime than it is on an annual average. So typical rainfall in January is less than a half an inch across most of West Texas, whereas we're talking as much as 4 to 5 inches, even 6 inches along the Louisiana border. And if I just go through month by month through the year, you see that pattern holds up through February and March, although we get a little bit more moisture coming into the western part of the state in March and April. Here's May, and now there's a lot of blue across the state. May and June tend to be the wettest months of the year on average for Texas. Of course, May is severe weather season. And June, we start getting some tropical moisture feeding in as the ocean temperatures warm up a bit and the humidity increases. So there's June. July, we actually dry out a bit in East Texas. And West Texas gets wet. Go back to June again. You can see West Texas has, particularly in the Trans-Pecos, increased precipitation, and even the desert in Arizona and New Mexico are much wetter. This is basically something that's called the Southwest Monsoon. It's sort of like what happens in India, only on a smaller scale. Basically, with the land heating up during the summertime, that creates low pressure, and air gets drawn in both from the Gulf of Mexico and the Gulf of California. So you get thunderstorm activity throughout Arizona, New Mexico, and West Texas. So basically, all of West Texas west of Amarillo and Fort Stockton has its wettest time of year in July and August. Then September, we get another problem, which is hurricanes. Sort of a second peak in rainfall in September and October, as tropical disturbances can come in, and rainfall in September and October is a maximum in the United States, basically in much of Texas, Oklahoma, and Arkansas, before we get back into wintertime where the moisture moves farther east for the most part. Now, on the annual basis, and even in individual months, it's mostly just a west to east variation. The one difference is probably predominantly in July and August, where there's a lot of precipitation, mainly along the coast, because of thunderstorms forming along the sea breeze during the summertime. It gives us the problem with weather forecasts in the summer. You get 20 to 30% chance of rain every day because you can't forecast individual thunderstorms. Weather's a bit more easy to forecast during the rest of the year because it's generated by larger scale weather systems that are much easier to simulate and see coming from, you know, several days in advance. Okay, Texas rainfall changes from west to east. Texas temperature changes from south to north. Now, this is January average maximum temperatures. And in the Texas Panhandle, we typically are seeing temperatures in the low 50s on a typical winter day. Whereas in South Texas, it's going to be temperatures in the upper 60s to low 70s. Nighttime temperatures, similar variation from north to south. And north-south variation is largest in the wintertime because the sun is basically over the southern hemisphere. And when we get air from the Arctic, that air is really cold. In the summertime, the sun's almost overhead. And so there's actually very little change in temperature from south to north. It's just as hot in Amarillo on a typical summer day as it is in Brownsville, even though humidity is a bit different. Okay, so that's the climate background of the state, what the basic weather patterns are and where they come from. Now let's start talking about how climate changes from year to year and decade to decade. That includes what we call climate variability, as well as climate change. So as you go from the top to the bottom of this list, you got things that affect the climate relatively short time scale, season to season or year to year. And as you go down to the bottom, we got things that affect the Earth's climate on time scales of 20,000 years to 100,000 years. The most rapid one, and the one that affects our weather the most from year to year, is El Nino. Scientifically, you might hear it referred to as ENSO. That stands for El Nino Southern Oscillation. The way El Nino was originally discovered was by Western scientists was somebody noticed that the air pressure around the island of Tahiti, around about here, varied from year to year. Some years it was high, some years it was low. And the air pressure in Darwin, Australia, varied from year to year, but in the opposite direction. When Tahiti had high pressure, Darwin had low pressure, and vice versa. And so that was documented in the 1920s, and it was called the Southern Oscillation because of the variation of pressure in the southern hemisphere. Meanwhile, for thousands of years, fishermen in Ecuador and Peru knew that the temperatures along the coast tended to change dramatically on occasion. Normally, you've got cool upwelling waters that bring lots of nutrients and lots of fish. But every once in a while, the upwelling would shut down and sea surface temperatures would warm up. And not only would you get a reduction of fish supply, you'd also occasionally get heavy rainfall as a result of those warm tropical temperatures would cause devastating floods. And they called that phenomenon El Nino in recent centuries because it tended to develop during the fall and peak during the winter around Christmas time. And the words El Nino referred to the Christ child. So finally, in the 1980s or so, scientists pieced together that those were basically two aspects of the same phenomenon. Basically, temperatures in the ocean in the tropical Pacific would, on occasion, warm up dramatically. These are temperature variations for 6 different El Nino years. The reds are where temperatures are warmer than normal. This deep red is more than about 5 degrees Fahrenheit warmer than normal. And we're looking at an enormous part of the eastern and central tropical Pacific. You know, Texas is just a small corner of the map here. And when you have such a big warming of the ocean, that affects the thunderstorm distribution, and that affects the winds, and the wind patterns in turn affect the ocean temperatures. Because when the air pressure equalizes over the Pacific and you get lower pressure over the eastern Pacific, that sort of shuts down the trade winds. And without the trade winds blowing from east to west, you no longer have the upwelling, which leads to warmer temperatures along the coast, and that sort of reinforces the pattern. So the ocean is affecting the atmosphere is affecting the ocean in this feedback cycle. And this is really the only place on the earth where that sort of thing can happen. Fortunately, it's sort of self-limiting because you can only have water sloshing across the Pacific for so long before it wants to slosh back. So typically, El Nino only lasts for a year or two. These are 6 strong El Ninos. After a while, scientists being scientists decided they wanted to attach a name to the opposite phenomenon when temperatures are unusually cold in the tropical Pacific, because they can't either be normal or warm. They have to average out to 0. And so they call this La Nina as being the opposite of El Nino. And the name stuck. And so we had years in which temperatures are unusually cold. There's very little thunderstorm activity in the tropical Pacific. It's all over Indonesia and northern Australia. And the trade winds are unusually strong. And that means the upwelling is unusually strong. That means the ocean temperatures stay cold, and you got that reinforcing cycle basically working in the opposite direction. So I've touched on how this affects the climate of the tropical Pacific. It's affecting winds, it's affecting temperatures, it's affecting rainfall. But you're affecting this much of the tropics, that affects basically the whole temperature difference between the tropics and high latitudes. We get a jet stream because we have a big temperature difference. So with this temperature difference reduced in a La Nina, for example, the jet stream is weaker and farther north. Now, our weather in the wintertime in Texas comes from occasional disturbances on the jet stream, triggering storm systems, causing cold fronts, and so forth. So when we have a La Nina with the jet stream farther north than normal, we end up with fewer storms in the winter. We end up with relatively warm and dry conditions in the wintertime. Conversely, with El Nino, we've got an enhanced temperature difference from the tropics to high latitudes. We've got a stronger jet stream. Jet stream tends to be farther south as well, and we get more rainfall during the winter as a result of that. Yeah.
You mentioned that the Nino is at its peak around December. So the Nino will be like summertime, mid-year?
No, both of them actually tend to peak in the wintertime. So both El Nino and La Nina tend to be strongest in the wintertime. They're sort of mirror images of each other that way. But yeah, the seasonal cycle, we do typically have warmer temperatures in the tropics in July and August than we do in January and February because the trade winds vary in strength across the year also. Yeah.
Does La Nina have an adverse effect on ecology, just like the El Nino did, as fish and bugs and stuff like that?
Question was, does La Nina have an adverse effect on ecology like El Nino? It affects things because we end up with a different climate with La Nina. You don't have, so you're more likely to have floods during an El Nino year. You're more likely to have droughts during a La Nina year. So we can sort of pin, let me follow this up. We can pin down those numbers by looking at the average conditions during an El Nino. And this is how rainfall during November through March is different on average during an El Nino year. We see 3 to 5 inches more rainfall during the cool time of year, November through March, during a El Nino. And that's true for the southern United States in general. As the jet stream moves farther south, those storm systems end up farther south also. Conversely, and also with the jet stream farther south, we tend to get more storms, and we have temperatures being a bit cooler also. Whereas with La Nina, it tends to be drier during the winter time across the southern United States. We, on average, have 3 to 5 inches less rainfall, and temperatures tend to be warmer as well. And that's average conditions. Of course, any given year you can have big swings of rainfall. So probably a better way of thinking of this is sometimes you'll have in La Nina normal rainfall in the wintertime, and sometimes you'll have rainfall that's 10 inches below normal. And by the way, this year is a La Nina year. We've had a weak to moderate La Nina. It's actually the second year of La Nina. And rainfall across the state of Texas has been very much on the dry side. A lot of West Texas is an extreme drought or an exceptional drought, which is a combination of La Nina making it more likely that we'd be dry, and then the weather ending up being dry on top of that. A couple other questions? Yeah.
Yeah, I'm kind of getting the picture that El Nino and La Nina kind of oscillate, temperature kind of oscillates. But my question is typically how many years between the start of one El Nino and the start of the next El Nino?
Question is, how big is this oscillation? How long does it take? And the answer is it's anywhere from 2 to 7 years. So you could potentially have an El Nino year, then a La Nina year, then El Nino year, or they could persist for a while. And it's not just El Nino or La Nina. The threshold for an El Nino is temperatures have to be at least 0.5 degrees Celsius above normal for several months in the tropics. La Nina is 0.5 degree below normal for several months. Anything that doesn't meet either criteria is called neutral. And as you might guess, that our average conditions are actually pretty close to average during a neutral year.
Thank you.
Yes.
How often is it reassessed for what average is?
Yeah, so for climate purposes, the standard is that average conditions are defined as the average for the past 3 decades. So our current period for respect to climate for normal conditions is 1991 through 2020. Those are the last 3 complete decades. So whenever someone is saying temperatures are 3 degrees above normal today or what have you. They're referring to relative to that period of time. And it was, you know, it was originally defined so that people could understand what to expect in the future. Nowadays, it doesn't quite work so well because temperatures are changing and rainfall is changing also. So actually, if you want to make an accurate seasonal forecast, you should predict that temperatures will be above normal, and usually that'll be correct. Yes?
Doesn't that give you what I call generational bias, where you're looking at such a short period of time in relative to weather? Because I've seen trends over the last 100 to 150 years, and rainfall is decreasing and temperatures are rising. So you're actually talking about high temperatures relative to a longer history. So when you say average, it's much warmer than it was 100 years ago. How does that? How do you get that message to the public?
Yeah. So the question for Rosie online was if you look at if you define your normal as being a fairly recent period of time, then present day temperatures aren't all that unusual. Whereas since temperatures have been rising for over a century, if you define your reference period as being like the 18th and 19th century, temperatures are quite a bit unusual. And yeah, that's why for weather, we tend to use a more recent reference period because weather is the variations on top of the climate conditions. Whereas if you're actually trying to talk about climate change, you want to refer to something going back a long time to say how much things are different compared to that. And yeah, you do get different numbers. And yeah, people's sense of normal is changing also. If you're older, you're probably perceiving weather as being a bit different from what you remember it. If you're younger, this seems like the normal conditions. Okay, I didn't mention it, but if you want to keep straight the difference between El Nino and La Nina, you can think of the L in El Nino standing for extra liquid. We get more rain in the wintertime. And the La in La Nina, less agua. You get drier conditions in the wintertime with La Nina. Summertime rainfall is what you really like to know because that really makes the difference between very dry and not dry. And it actually doesn't really matter much with El Nino or La Nina in the summertime as far as our average conditions, because El Nino or La Nina are affecting the jet stream, and the jet stream in the summertime is so far north, it's not affecting our weather at all. About the only thing El Nino or La Nina affect for us in the summertime is the likelihood of hurricanes. Because if you got stronger trade winds, you end up with stronger winds at higher altitudes in the other direction, and that wind shear tends to rip apart hurricanes and make them harder to get going in the first place. Bottom line on that is El Nino, we tend to have fewer hurricanes in the Atlantic Ocean. And with La Nina, we tend to have more. So when the seasonal outlook for hurricanes comes out, probably in a month or so, you will see a forecast for above more active hurricane season than normal because of that. Can't really predict exactly where the hurricanes will go a season in advance, but it's more likely the United States will get one or more hurricanes. We've actually had quite a few the past couple of years, and that you may see a third year like that. Okay, talking about the temperature changes, this is that didn't come out too well. This is a map of the temperature change over the past 40, 45 years or so. And the rate of increase here is between about half a degree Fahrenheit per decade and about 0.8 degrees Fahrenheit per decade. There's not much geographical pattern to these temperature changes. They're going up everywhere. They're not going up predominantly in urban areas, but it's fairly uniform. If we look at it as a function of time, I've got 4 different things on here. 2 of them are 2 estimates of global average temperatures. Those are the light jagged lines. The smoother light blue line is an average of a whole bunch of climate model simulations of global average temperatures, which on the whole lines up pretty well. It's smooth because it's averaging a bunch of simulations, and so the weather gets average. You can't predict when an El Nino or La Nina is going to be. So when you average together simulations that had a La Nina year and an El Nino year, you end up with average. The only dips that tend to occur are those caused by volcanic activity, which happened the same year in all of the historical simulations, such as, let's see, this was Mount Agung, this was Mount Pinatubo, and they also correspond to dips in the observed temperatures. The red line is Texas temperatures in dark red, and these are actually averaged over 9-year periods to smooth things out a bit, and it's still a bit more variable. It roughly follows what happened globally, but not quite. In particular, at least on this scale, the temperatures in the early part of the 20th century were warmer than one would expect for the globe, but that's sort of arbitrary how I did that. I could have easily just plotted a different reference period, in which case these temperatures would look cooler than the globe. And the possible reason for that, well, let me show you the couple more graphs of temperatures in Texas before I explain the reason why that might be. These are the annual average temperatures, a smooth version of them for maximum temperatures, daily maximum average, and then the daily minimum, and they both show roughly the same thing, although in the middle of the century, daily maximum temperatures took a dip, whereas minimum temperatures were pretty much steady. And if we look at the hottest temperature of the year, or the average hottest temperature of the month during the summer months, actually the change, we're just now barely getting above the long-term average for that. And we had quite high temperatures during the early part of the 20th century. 2011, you may remember, that's this point. And then the coldest temperature of the year, much more variable, but substantial warming trend. And you may remember 2021, we got kind of cold in February. And also, these horizontal lines are every 4 degrees Celsius, 4 degrees Fahrenheit. And there's a lot more for the coldest temperature than the hottest. It's showing you temperatures are much more variable in the wintertime than they are in the summertime also, by quite a large margin. Okay, so why do we get those differences in temperature and temperature trends? I think it's related to what causes temperature in the first place, which, well, gee, it seems obvious that causes daytime temperatures to warm up is the sun is heating up the air, but actually it's slightly more complicated than that. There's not much sunlight that gets absorbed by the air. And we know that because we can see. During the daytime outside, we can see distances. Light is passing through the air. The light is not being absorbed by the air. If the light were all absorbed by the air, then it would be dark at the ground because all the sunlight would have gotten absorbed before it got to us. the fact that it's able to go all the way through the atmosphere and make things nice and bright on the ground tells us it's not being absorbed by the air. And for that matter, if you're in a cave, they may take the cave turn and do the thing, hey, turn off the flashlight, turn off the lights, it's all pitch dark. You know that the Earth's surface absorbs light. It doesn't go through. So when it's absorbing sunlight, it's absorbing energy, which really can do two things at that point. Well, three things. It can heat up the ground, which it does to some extent. And the ground can heat up the air that's in contact with it, which can then, that warmer air can be, through turbulence, get distributed upward through maybe the lowest few thousand feet of the atmosphere during the daytime. That energy can also be used to evaporate water. And that's why the amount of moisture in the air tends to increase during the morning as water gets evaporated. And then, well, you might be thinking, well, wait a minute, during the afternoon, things tend to feel a lot drier, and at night they're more humid. That's true in a relative sense. The relative humidity is drier during the day because the moisture is getting mixed upward with the warmer temperatures. We're getting drier air from above come down. So our moisture actually tends to be smallest in the afternoon, but it peaks in the morning when you've had evaporation. That moisture hasn't gotten redistributed through the atmosphere yet. An illustration of that sort of thing is with this pair of satellite images. So the top image is looking at a portion of Washington and Oregon with the Columbia River that blew straight through the middle of it. And the satellite is detecting basically chlorophyll, and it's identifying vegetation that's growing. And you see a lot of polka dots, because this is normally a fairly dry region, but you have center pivot irrigation systems. And you've also got some broader scale irrigation here for this plantation in the lower left. And you know, it's very easy to tell where you've got active plant growth and where you don't. Now, if you look at the image on the bottom, it's a different color, but it really basically looks about the same. You can see where the same polka dots show up because the same pattern of vegetation is influencing what we're seeing here on the bottom, except was plotted, and you may not be able to see it because the label is way down here at the bottom behind this table, is land surface temperature. Satellite's actually detecting the temperature of the ground or the temperature of the plants and leaves above the ground. And the scale goes from the bottom end, the dark color is 18 Celsius or about 65 Fahrenheit. And the top end is 48 Celsius or about 115 degrees Fahrenheit. So basically the vegetation is cool. Where there's plenty of water evaporating, the plants are actively growing. And where the grasses are dormant and dry, like in this military depot, temperatures are very high. Essentially, you've got so much sunlight being absorbed, and some of it can evaporate water when there's water. But if there's no water, then all of it's going into heating the ground and heating the atmosphere. Yeah.
So most people talk about climate change and talk about CO2 levels. And I've recently read where, again, the amount of vegetation on the earth in certain places is having a dramatic impact on climate. Also, where if you go back 100 years or 200 years and you have large forests, tall trees, how much do you think that's making a difference in our climate change? Just the amount of vegetation that is missing from historical perspective.
Okay, so the question was, vegetation clearly is affecting climate, and we've seen big changes of vegetation over the past few centuries. How big of an effect is that having? It is having some effect. I'll actually be able to show you in a couple slides what the scientific estimate is of how big that effect is. I can circle back to your question.
Okay, thank you.
Yes.
On a similar note, are you gonna touch on the urban heat island by any chance?
I will talk about the urban heat island a little bit later on, but
Okay.
obviously we're sort of talking about it here, not calling it that, but yeah, in the urban landscape you've got less vegetation and more pavement and built infrastructure, and obviously unless it rains, you're not going to get any evaporation coming from rooftops or from parking lots or streets and so forth. So an urban area is going to tend to look like the drier parts of this image, where temperatures heat up faster during the day. And the fact that it's absorbing more energy also makes it tend to be warmer at night. There's a few other factors going on, but basically you get a heat island in most major cities. The bigger the city, the bigger the temperature effect, because you're affecting a larger footprint, and so takes air passing through the city has a longer time to be affected by it. The only exception perhaps is someplace like Phoenix in the summertime, where people are actually watering their yards. The desert's dry, and so it can actually be cooler during the day in a place like that.
Thank you.
Mm-hmm. Yes.
Just out of curiosity, you would have to know what that white structure is on the top image.
The white structure.
It's probably about 4 o'clock.
So would you repeat the question for the people listening in?
You're talking about this?
Yes.
That is actually a reservoir. For those of you who are looking remotely, see if I can get a mouse going here. The mouse doesn't want to show up. But if you see the words lock and dam and then go down from those about a third of the way down, there's a spot that's white there and it's dark down there. The blue here for the Columbia River was shaded in artificially. But yeah, you can spot that as a reservoir because it's cool, as cool as anything else. So it's obviously, you can evaporate a lot of water from a reservoir, so it's staying mild. Okay, so we had a question about climate change, and just the basic rule about climate change is that for our planet, the amount of energy we're absorbing from the sun almost exactly equals the amount of energy that we're losing to space. And we're sort of at a disadvantage talking about it because it's easy to see and detect the fact that we're gaining energy from the sun, because when the sun's out, the Earth's heating out, we can see the light that the sun is emitting. The Earth is also emitting energy, but it's in the infrared part of the spectrum, so we can't actually see it unless you've got a satellite, well, like this, where you're actually, it's not sending down thermometers and measuring temperature of the ground. It's measuring the intensity of the radiation being emitted from the ground and passing through the atmosphere. There are some infrared wavelengths. The Earth is emitting radiation that basically the atmosphere is transparent to, just like it's mostly transparent to sunlight. There are other infrared wavelengths where the atmosphere absorbs and emits, and so what the Earth loses to space is partly what's coming from the ground and partly what's going from the atmosphere. And if you've got more energy coming in than going out, then the climate system is going to tend to warm up. If you're losing energy more than you're gaining it, it's going to cool off. At least that's an intuitive concept. the nice thing about the climate system is the warmer it gets, the more it's radiating energy, just like a 60-watt light bulb will be cooler than a 100-watt light bulb. So fundamentally, the climate system is stable. It's going to be trying to reach this temperature where it's able to emit as much energy as it's absorbing. Now, we've seen climate system change temperature by about 1 degree Celsius or 2 degrees Fahrenheit. That's the bar on the far left. So the observed change relative to the latter half of the 19th century. And that's pinned down fairly accurately to within a couple tenths of a degree because we've got good enough observations over enough of the Earth to be able to estimate that fairly accurately. Now to figure out what caused that, there's basically 2 approaches you can take. One is you can run an experiment with a climate model and say, well, gee, what if we plug in everything we know happened? Volcanic eruptions, changes in sunlight, changes in what's in the atmosphere, and do that. Can we reproduce the observed temperatures? And I showed you something like this already with that graph. Climate models come in pretty much the right ballpark in terms of how big the temperature change was historically. So their estimates are decent in that regard. Then you can play around with things and say, well, what if we don't change the atmosphere? What if we don't change sunlight? Or what if we don't change volcanic activity? And what you get from that are, if you only change the gases in the atmosphere, in which case here we're specifically talking about carbon dioxide, methane, and things like that, you actually get more warming than you simulate if you include everything. And the main reason for that is this other stuff in the atmosphere, mostly aerosol particles, things that make haze, that tends to prevent sunlight from reaching the ground, and so it's a cooling mechanism. And that combination basically gives you what we observed. Things like sunlight and volcanic activity can have big changes from year to year, but they don't seem to have contributed to a long-term trend. Likewise, El Nino, La Nina, that averages out over the long term. It's not contributing to the trend either. Second way of doing it is with basically looking at it from the context of the energy in and energy out. You can actually calculate from physics how much energy is being absorbed and how it's being affected by individual contributors. And so carbon dioxide, we can get a number out of that. Methane, other greenhouse gases, particles such as sulfur dioxide. Here's land use and irrigation. So on balance, we have land surface changes have caused a cooling trend of about 1/10 of a degree, give or take 1/10. And that's a combination of the tendency of going from forest to grassland and cities, which is a warming effect because you get less evaporation. But then we also have large amounts of irrigation taking place, which, as you saw, was a cooling effect. And on balance, it seems like the irrigation effect slightly wins out.
Can I ask,
Yeah, go ahead.
is your punchline at the top, observed warming is affected by human activities, or what does that say up there?
Yes, that's what it says.
Okay.
Let's see if we can move. See if I can move that around. I think I can.
It's okay, don't, oh, yeah, okay.
Of course, some things you'll see and some things you won't. Ah, there we go. All right.
What is black carbon?
Pardon me?
Well, on the right-hand graph, I see ammonia and then black carbon.
Oh, here? Yeah. So ammonia is something that comes from fertilizer and from feedlots, and it tends to cause tiny droplets of ammonia basically in the air, so it's a small cooling effect. Black carbon is what we would conventionally call soot, basically. So there's also smoke, and it's tiny particles also, but the key part there is it's black. So unlike droplets of water, it's absorbing sunlight, and so it actually tends to have a warming effect.
And what's organic carbon?
Organic carbon is referring to things like isoprene or sorts of carbon-based pollution that comes from the industry in Houston and so forth.
Bigger molecules, not CO2?
Right.
I got it, okay.
Sure. Okay, so to figure out future climate, you actually have to figure out a whole bunch of stuff. What's going to be in the atmosphere in the future? You know, what else is going to happen? Solar, volcanic activity, so forth. How big is the climate system going to respond to that? And what are the consequences of it? I'll just touch on a few of these aspects. First, what's going to be in the atmosphere is not really a climate scientist question, because that's sort of a societal and technological question. So what we do to answer the other parts of that set of questions is say, well, suppose we have this in the atmosphere, what would happen? Suppose we had this. And it's not just picking a number out of the hat, basically. You're actually wanting to figure out, well, let's see, how would we get lots of carbon dioxide in the atmosphere? What would the energy sources look like? How would society develop? What sort of economic activities would there be? And right now, we're emitting about 40 gigatons of carbon per year globally. And the range of scenarios we got for what might happen in the future go all the way from 3 times as much emissions in the future to actually removing more carbon dioxide from the air than we're emitting through things like carbon capture and sequestration. And those scenarios involve not just carbon dioxide, but also other important gases like methane, nitrous oxide, and sulfur dioxide. And you can plug each one of these scenarios into a climate model and get estimates of the consequences. And this is what you get from that. It's a much smaller dramatic range. Basically, at the low end, if you're sucking carbon dioxide out of the atmosphere, you're actually going to have a little bit of a cooling effect. At the high end, where you're basically burning as much fossil fuels as you get your hands on, is a warming effect, getting us up to several degrees of warming. Now, the range of possibilities here is fairly large. We're sort of in this sweet spot where if the change were relatively small, there'd be hardly noticeable effects, whereas up in this range you get fairly dramatic impacts because over, say, geologic time, climate has varied from something close to present day temperatures to maybe temperatures about 5 or 6 degrees cooler during an ice age. And so, our ecology, in a sense, is adapted to fairly slow long-term changes in the lower part of this temperature range. But it's not adapted or hasn't had to experience these relatively rapid changes going above the high end of that range. So that's what makes climate change consequential for the natural environment. Yes?
Based on the people who put this data together, I know that's the range. What is the probability of, I'll say, the high and the low end?
Yeah, the scientists studiously try to avoid answering that question. They're willing to answer the question of, well, if you have this much emissions, what's the range of temperatures that's likely to result? And basically, it comes out to if you double carbon dioxide concentration, you end up with somewhere around 2.5 or 3 degrees Celsius warmer temperatures. But the reason we don't have probabilities associated with the rest of it is these little code numbers here refer to potential ways society might evolve. For example, this one involves very high economic activity, the third world becoming fully industrialized and prosperous and so forth. This one involves lots of regional rivalries with still fairly large imbalances in economic activity. This involves prosperity, but transition to a green economy with cooperation throughout the globe and all sorts of different aspects. So, you know, good luck attaching probabilities to those scientifically. You know, as we go along, some of them become seemingly more likely than others. For example, the Earth has, societies on the globe in the past few months have seen very little inclination to cooperate with each other globally. So that may be driving us away from something like this scenario and something like this scenario to one of the more middle ones. But yeah, it's really hard to say, hey, this is what's going to happen. Good luck predicting society in 80 years. Yeah.
In terms of the global warming and cooling in the ice ages, isn't it going to eventually be inevitable that we will heat to a point that we will go back into another ice age? Because the heating will, right? I'm coming at this as a geology perspective, so I was just curious if you have thoughts.
Yeah, sure. So the question is, are we inevitably going to cool because we go through these cycles of ice ages and interglacial periods? Yeah, and the time scale on that is what I referred to in terms of tens of thousands of years. And at least geologically, we are nearing the end of what ought to have been an interglacial period, and then with seeing cooling. And apparently, actually, the past up until the Industrial Revolution, the past 22,000 years was predominantly a cooling trend. What we call the Little Ice Age might actually have ended up being evolved into a big ice age without global warming. It actually seems like we're having a big enough impact on the climate system right now that we have basically, and it's going to last long enough, we basically missed the bus. So that the opportunity to cool into the opportunity or danger of dropping into the next ice age in this cycle is gone by. And so it's going to be another maybe 30,000 years before the next orbital opportunity comes along for ice to start building up in the northern hemisphere.
Thank you.
Mm-hmm. Yeah.
On this table specifically, I know this is all theoretical, but it shows, you know, between halfway to a degree of change to, in 2015, a full degree of change. If there's a 85-year period there where we go up almost 4 degrees, how will that affect the weather on a global scale? I know that's all theoretical.
So the question is, you know, so historically we've seen about a degree of warming, and the upper end of the graph here is looking at 3 or 4 degrees of warming. What's the impact of that going to be? So thank you for letting me transition to the next part of my presentation. Basically, at least in terms of the numbers, like how big the impact is on temperature, rainfall, climate, it's essentially additive in the sense of 2 degrees of climate change produces twice as big an impact on local conditions as 1 degree, twice as big a change in extreme weather as 1 degree. But responses tend to be nonlinear because you already can tolerate natural variability over some range, and then as you go beyond that, then you start passing thresholds where systems are less able to adapt. So for example, right now climate change has been small enough that we've seen really no impacts on global economic activity that we can tell. But that's expected to show up if we get to 2 degrees of warming and beyond that. Meanwhile, sensitive ecological situations such as tropical coral reefs have already seen large impacts, and those are expected to become irreversible impacts effectively as we get beyond 2 degrees. So different things kick in at different times, but they become harder and harder for natural or human systems to deal with as you get to higher temperatures.
Thank you.
And this, by the way, is just illustrating how you get the same basic pattern with 1 degree warming as you do with 4 degrees. It's just more intense at 4 degrees. And with rainfall, basically the same patterns of change. It's just more intense as you get to warmer temperatures. So let's take a look at Texas extremes in particular. And for the sake of a report for Texas, this is available on our state climatologist website, we focused on historical trends because people are generally much more trusting of the historical data than they are of climate model simulations, which are real. But it is possible to basically have a long enough record. In many cases, we can detect these trends being and attribute them to climate change. So I showed the hottest temperatures and the coldest temperatures already. That particular cold in 2021 is one I want to give an example of how we actually sort out climate change impacts on what we see. So there's 3 basic lines of evidence that you can rely on. And what you want is for all 3 to agree with each other. If you just got evidence from one line of evidence and you don't have the other 2, you can't be very confident about what's going on. So the first thing is there a clear historical trend? And for that to be the case, you need to have the trend being large enough that you can detect the trend compared to natural variability. And you also have to have good enough data going far enough back to be able to do that. Secondly, your models project a consistent future trend. Well, for that, you need to have something that models can simulate. And third, is there a sound physical understanding of why there should be a trend? So for that, you'd want something that was fairly straightforward, such as, for example, local temperatures ought to increase if global temperatures increase. That's a fairly straightforward relationship. And you don't want to just have these all pointing in the same direction. You want to have them predicting the right magnitude. And if everything lines up, then you've got high confidence. And if it doesn't mean that nothing is happening. It means that you can't really tell and attribute it to climate change, or maybe nothing's happening. And for extreme weather, there's sort of 2 different types of ways climate change affects it. One is the direct way with temperatures, and I refer to that as basically the way things are. So with warm air, it holds more moisture, and so you can get heavier rainfall. That's sort of a direct effect of climate change. And then dynamic, the way things behave. And so, for example, with a different climate, you can have more intense hurricanes, which would in turn affect rainfall, but in a less direct way than just having higher temperatures leading to more intense rainfall in general. Second example I've got for these is referring specifically to winter cold. The Arctic is warming faster than the rest of the globe, so we should expect to see when we get Arctic air that it's milder than it used to be. As far as dynamics, we may get weather patterns that lead to cold weather becoming more common due to how Arctic sea ice is affecting weather patterns. And those are competing effects, right? This would lead to milder winters, and this would lead to colder winters, or at least colder extremes in the wintertime. And both of these could be going on at the same time, and whichever one is the stronger effect would be the one that would be determining the trends that we get. So this was February 2021. This is basically statewide average temperatures, hour by hour for a 2-week period. And you can see warms during the day, cools at night. Temperatures were just hunky-dory for early February. And then they dropped, and they dropped some more. And this looks like a bunch of icicles falling from the roof, which is about right. Average temperatures across the state dropped below 10 degrees. Much of the state dropped below 0. Stayed cold for several days and then warmed up again, and everything melted. This is another way of looking at the data, except instead of looking at 2 weeks, I'm looking at 122 years of temperatures in Texas. Here are the lowest temperatures averaged across Texas during February 15th and February 16th. Each one of these dots is a particular day. I've only plotted things below 32 degrees Fahrenheit, so you're only seeing the coldest days of the year. And you can tell how big a year is because we get basically one set of plot dots for each winter. 1989 was colder than 2021 on a particular night. We had a couple colder periods back in the 1910s, 1920s, and then 1899 over on the far left, the average temperature in Texas got down to about 0 degrees Fahrenheit, and Galveston Bay actually had ice forming on its surface. That was a fun time, I imagine. I'm not going to go into the impacts of February 2021 in detail, but just to point out that what stands out in this plot is not how unusual 2021 was. Yeah, it was unusual. Maybe only happened 3 times in recorded history. But look at this gap here where we didn't have any moderately extreme winters compared to what was frequent up through the 1980s. So I think part of the problem in terms of the impacts we saw was that we had this period of 3 decades where the system wasn't stressed by moderately extreme cold. And then when we did have extreme cold, it was really extreme and brought us to a near collapse of the power grid. Yeah.
Quick question. For when earlier I had asked that you had said the averages for over 3 decades. So this is an example in which that 3 decades are not necessarily inclusive as to overall averages. Is that correct?
That's right. This is an illustration of how 3 decades is not long enough if you're worried about extreme conditions.
Okay, cool.
For averages, it works pretty well. And by the way, I do wonder about what hardiness maps will look like when they're updated for 1991 through 2020. Be careful, because the plants will look like from that, but they'll survive a lot better than they probably actually will. Yeah.
Were any conclusions drawn between that 1899 thing and the 1900 hurricane that destroyed Galveston?
The question was there any connection between that 1899 cold and the 1900 hurricane? Probably not. Now, if we had a hurricane destroy Galveston last summer, it might have been kind of interesting, or this summer, I guess. But yeah, that was long enough apart that it probably wasn't connected. Another thing that probably wasn't connected was the 1899 Hearn flood, where we got about 35 inches of rain from the remnants of a tropical storm. That was a devastating event for the Brazos River back then. Okay, let's see. So we're up to 9:20. So I will talk extremely quickly for a little bit here. So snowfall is actually decreasing also. And extreme heat is increasing. It's about doubled if you count the number of 100-degree days over the past few decades. And Tornadoes, we can't tell because we don't have good historical records. Climate models can't simulate them, and there's not a sound physical, theoretical reason for how tornadoes would be affected by warmer overall temperatures. Rainfall has historically increased in the eastern part of the state, and soil moisture is projected to decrease across the state. We don't have good historical soil moisture observations, but climate models are pretty consistent in this, which is a reflection of essentially the higher temperatures leading to more rapid evaporation from the ground.
What does the crosshatching mean?
The crosshatching is where at least a quarter of the climate models have something changing in the opposite direction from the majority. So for example, with runoff, climate models don't have a clear consensus in Texas, although more of them say we'll have more runoff than say we'll have less runoff. And that's a consequence, presumably, of rainfall becoming more intense in general. So you got this you know, if you have roughly the same amount of rainfall overall, but the intensity increases, that means you tend to have the heavier rainfall and you get more runoff, and then you have drier periods where you've got evaporation, and so soil moisture goes down and runoff goes up, even though the total amount of rainfall stays the same. And by the way, historically, we can see that there are trends in very heavy rain also. If you look at the amount of rain that statistically you'd expect to see on the wettest day of the century, in southeast Texas, that's about 17, 18 inches or so. Up where we are, it's more like 13 or 14 inches of rain in the wettest day of the year. I know this can be true because in College Station we got 14 inches of rain in 1994 in 24 hours. And the trends are somewhere around 10 to 20% in terms of the magnitude of the expected once in a century rainfall based on the long-term trends that we see in extremes across the whole southern and southeastern United States. Looks really bad for East Texas and Louisiana, but that's probably basically just the bad luck of the past few years with Hurricane Harvey and all the rest of it, because climate change doesn't cause things to happen that locally. It causes the broader trends, and weather causes people to be lucky or people to be unlucky. Okay, so speaking of being unlucky, this was a flood in Fort Collins, Colorado, back in 1997. And at the time, there weren't any good rain gauges under this stationary thunderstorm that was sitting in the foothills above Fort Collins. And about a dozen people lost their lives as a result of the flood, which wasn't warned by the Weather Service. And this is the rainfall pattern that they estimated after the fact, with 10-inch rainfall total in a few hours, just above Fort Collins. And so my counterpart in Colorado, the state climatologist, said, well, gee, we were able to do this because people had rain gauges in their backyards. What if that information was actually available and collected on a matter of course? And so this is the next flood in Fort Collins, and this is the distribution of gauge totals that were available at the time through CoCoRaHS. This is basically a volunteer network where you take an observation once a day, usually in the morning, 7 or 8 a.m. is when they want it to be, with a standard rain gauge. And the information gets collected and becomes part of the climate record. So right now we have, right now, let me go to the map. This gets used for weather warnings as well. Obviously, if you only get reports once a day, it's not very useful for warnings, but you can also submit significant event reports where say, we just got 2 inches of rain in an hour, and that information goes directly to the console at the Weather Service office. They know what's happening. And so here's an example where in the New Braunfels office, they warned on rainfall, 7 inches of rain reported from CoCoRaHS, and they were able to tell that this one little thunderstorm was actually dumping a massive amount of rain there, was causing flooding. So here's a recent distribution of rain gauge totals from CoCoRaHS in eastern Texas. The Rainfall's office really got sold on it, and they did a lot of outreach on it. These tend to be clustered in populated areas, and part of the problem is for this part of Texas, the radars are pretty distant, so that there's not ability to see what's happening in the lowest several thousand feet of the atmosphere and how much rain is actually reaching the ground. So we've got some gauges around Huntsville and Montgomery and Lake Livingston, but the more the better to fill in the gaps in this network and be able to tell exactly how much rain is happening. And we use it in our office to figure out what's the drought conditions. Rainfall estimates from radar is pretty poor this far away from all radars, so the gauge totals are actually very critical for getting information. So if you're interested in this, and you can get Master Naturalist credit for participating, the website here is CoCoRaHS.org. The acronym stands for Community Collaborative Rain, Hail, and Snow Networks. And they've got a bunch of how-to videos. The gauge itself only costs about something like $30 or $40. They want it to be standardized because this is going to be official observations. And it's a way of basically staying on top of what's happening with the weather and climate. And you can also enter information on what you're seeing phenologically, when plants are blooming, when there's water in the streams and that sort of thing. And that becomes part of the permanent record. You can even look back a year earlier to see whether what you're seeing now is the same thing as what you saw back then. And I think with that, I made it to the limit of my time. Thank you for asking questions during the middle. Are there any final questions at the end here? Yes.
All right, as in your role as Texas State climatologist, are you the guy that decides which counties have burn bans when they go?
Question is, am I the guy who decides which counties have burn bans? The answer is no. That's the county judges and commissioners court. I do play a role in assessing the drought conditions across the state for the U.S. Drought Monitor. I collect and provide recommendations to the Drought Monitor author, so I can take some of the blame for that, but not for the burn bans. Okay, well, thank you. I hope there weren't any questions online because I didn't hear any. If there were, I missed it. Sorry, but you can email me at n-g@tamu.edu if you want to follow up with anything.
Repeat that, please.
n-g for Nielsen-Gammon @tamu.edu.
Thank you.
We did have one question. Someone,
Is out on the table if you want to take a look at one and be part of the CoCoRaHS network. I can see my dot home, John.
Just
And how much
more
were those? 32, 35?
I have to look at the email she sent us, because she got a discount and she bought a case. It's a little bit less than 30.
Does the rain gauge have to be somewhere like not under a tree?
Yes,
Yeah.
it needs to be in your backyard,
Well,
and
yeah,
stay
not
away from your house. And so it's got to, obviously, if you put it under an oak tree, that sounds like a very negative thing. Or under your eave, but there's instructions on CoCoRaHS about where you find the right place. And also, like I've got mine on a wooden post 3 feet off the ground in the middle of a cleared area.
Yeah, I don't have one because I've got trees throughout my yard, so there's no good place to put it. Bad data is worse than no data.
What? You don't have one? That's no doubt on it.
Okay, y'all, we're gonna take about a 10-minute break before our next speaker.
Okay, was there a question online?
There is one question online. Misty asked if you said that the slides were available on the AMN climatology website.
Okay, I don't have the slides posted, but if you send me an email, I can share them with you with a Google Drive link.
Okay, that sounds
Again,
great.
that's n-g@tamu.edu.
I will drop that email in the chat, and we do have, we're recording this session, so people will be able to watch it later.
Okay, great. All right, thank you.
Awesome. Thank you so much.
Sure.
So with this, Carolyn?
She might be muted.
Chris Matheson back in the day.
Yep.
Right when I started doing this 5 years ago, I saw who wrote the chapter, and I sent him an unsolicited email and asked if he had any slides. He sent me a memory stick with like 400 slides on it. Whoa. His perspective on geology was a little different. As an engineer, sort of an engineering geologist, sedimentary.
Yep. Pretty good, pretty good.
He passed away, though, I think, right?
Hey, Scott,
Yeah.
I'm going to go ahead and log off. I want to make sure that everything stays working for you when I do, because I need to get ready to fly. So let me go ahead and I'm going to say leave meeting, and you let me know if anything hinky goes on. You can just text me, okay?
I should be okay.
Oh, and the rain gauges Lisa just asked, they're normally $40, but because I bought them in bulk, they're only $32.
32. So if anybody gets me 32, they can have one today.
Yeah, there are only 6 left. So
32.
It is, I didn't explain it. It wouldn't
Do you
help
want to
people
do
much.
cash
Yeah,
or
it stands for shared socioeconomic.
either one is fine. Either one is fine, Scott.
Yeah, so you have much I can do. Give Lisa $32.
I come up with a whole lot of different things. That wasn't one of them.
No, it wasn't.
All right. Safe travels, Carolyn. You gonna hang around or yell?
I ordinarily I might, but I'm giving another talk at 11.
You have a busy Saturday.
Yep.
Okay, thank you, sir.
You're welcome.
Really appreciate you driving over.
Sure.
That was really excellent, thank you.
You're welcome.
Oh, yeah.
I'd be lost without it.
It's all ready to go for you. I think it's on the good. That's right. Yeah, it's on the good. No, yeah, that's on that one. Yeah. Right one right there.
Some years ago.
Oh, there it is. Here, shoot. It's a little bit different than the Dell I got. It's a little,
I just asking. Bump it up from her in the little popsicle.
you can minimize this. There. That it for part one?
Yep.
She got somebody else coming in. I just don't know. This guy. Should we write that down? We are screen sharing, and I think there's a display setting where it takes it off of this presentation. Duplicate stuff. And we'll just move this guy. Let's see if it's controlled. Okay. This happened at Jones Forest where it's quit working. You know, it needs to be like in your. Yep. What happened with his is the presentation was so hard, it had completely loaded with the network. And
Introduce me or the bio.
we'll just casually introduce you and then you can tell them all that. Yeah. My only question is, when are you gonna move from Sugar Land to New Orleans?
Well, I'm not moving to LaGrange.
You got a place there?
Yeah, that's where I'm here to work out the farm section.
You gonna sell your place or keep it?
Self-place used to be. Yeah, we hope to start building this year.
Good for you.
Wife's gonna retire from the junior, so. Son's taking over the business, so.
Good for you. So you gonna stay in the family?
Yeah. At least from the time when I had a bunch of people want to buy it. Try to keep it quiet.
Keep the tradition alive. Well, that's good. Is your son a soil scientist, geologist like you?
He took geology, he got minor in organic horticulture at the state. He had some soil science in the geology courses. But no, not like to be that way. But he's very good at operations, so equipment management, maintenance.
You've got that. You've got the model set up already. That's good.
I'll be able to build.
I retired 5 years ago. That was the best thing I ever did. Life changing. For me, it did.
Yeah. I went back off my top. It's worked out there 30, 40 talks a year. My wife, eventually get it up. So this may be the last talk I'm giving for forever. Not forever,
But does your son like to do this kind of stuff?
So I don't have to interrupt the presentation. Would you define PEDs for me?
And it's just a unit soil structure. A small.
Is it short for pediments or something now, or just?
It's just a nickname that comes from the Latin somewhere. I don't know.
Oh, okay, thanks.
But it's just a small unit of soil.
I saw that, you know, and throughout the text, I couldn't see that there was a definition for it, so, okay, got it, thanks.
And I'm here to ask about mulch for my husband. He was looking at the Nature's Way site. We put cedar mulch down last year before we knew much about anything. What would be from the website from Nature's Way? What would be good for our garden? And there's a whole bunch of different stuff.
Cedar mulch is bad for the garden.
Yes, we know.
Oh, okay.
So we want to switch to.
The best determinant?
Yes, from
The native mulch is composted.
the native mulch
Yeah. So here's what it looks like. It's been composted.
before we knew what we were doing. Trying to predict.
This mulch is so rich, people aren't fertilizing it.
Okay.
So rich in water. But it's also, people don't realize, if I put it through like a flower system, separate the particle size, 50% compost.
Yes.
That's not true.
Is that your lake low compost?
No, this is the mulch, composted mulch.
Compost. Okay.
And this, it has the microbes in it that take clay, break it down and turn it into beautiful lumber.
How long does it take?
It's
Eight.
about a year.
Well, it sits in a pile over for a year.
Most of 18 months for our compost.
You see me a lot there.
Yes, I recognize. I can several of them out here, you know.
Yes. My kids and I will go and buy flowers. Okay, good. Thank you so much. Appreciate it.
No, I'm not in a hurry. I mean, just whenever.
So are you gonna raise cows on LaGrange? Or you just gonna have
I
a,
haven't decided. I do want some animals. I got 113 acres, about 65, 70 old pasture suburban prairie.
good for you. That'll be a big project.
So I do want some grazing animals. This is maybe one horse and not maybe some of the non-migratory buffalo.
Yes, sir. So once you have them rain gauge, and then you all yes, sir.
And then ask you, you'll get your GPS.
So do you think, as far as
No,
joining
no,
the,
once you do that, the rest of it's free.
once you buy
It's not just charts, it's you can look at maps all over the United States and see what people know.
so once you buy the gauge, then you're ready, just log in and make an
Log
account.
in, make an account, just type in CoCoRaHS. There's even a video. How to measure your range, that kind of stuff, and they do it this way because all those electronic systems, they got electronic systems, they're almost never accurate. This is accurate. What happens if you get, big change, and one going down the middle, and what happens if you get one down the middle? And those ones, there you go.
I had several questions about how to mount it. Can you just tell me how you did yours? There's a video. Words of it, yeah.
Yeah, so there's a couple of
Because
things.
I'm now told.
The biggest one is video on how to use it.
Okay, and did you?
Yeah, and there's $65.
See, that's what I thought. I was like, I've seen that man. I've read your blogs on the Lazy Gardener. Yeah, cool. Yep, that's what I thought.
Oh,
Cool,
you're
cool.
enjoying
Perfect.
Down the proverbial bookmark.
Super company.
Well, thank you.
Mhm.
If they really want.
Okay, just give, okay.
See, once it gets full, then it's going down.
And, somebody that's paying it.
Okay, all right.
Is everybody outside? Yeah, send them in and we'll get started. I'm all of a sudden a CoCoRaHS expert.
Hey. Used to
He actually, we had never done classes. We never did planning last year, especially in the Zoom year with the pandemic. We never done a couple of things. We had a guy that came into the archaeology. Especially on the station. So if you're similar to that, you're in station. And then, I forgot who recommended, I think the lawyer did that, who recommended John Henry. He was like, yeah, I'll do that. And he drives over. You'll have to find a replacement view.
Okay, so you're gonna have them mounted this
Yeah.
and bring
Is everybody
money,
back?
or just sign their name and then they can, you wanna do the whole thing, or do you want me to do the money thing? Tell them to, they can go ahead and have one and just pay Carolyn.
Is this everybody? Are they back?
Hey, everybody,
You're back?
they can't tell me if they're not.
Okay, we had a couple of questions on CoCoRaHS, and I turned out to be the expert because I just happened to have one. I only did that because I saw John give the talk last year when I was training director before Lisa. Somebody better is in charge. The CoCoRaHS thing, once you get that rain gauge, if you go to the site, CoCoRaHS.org, and even if you don't remember how to spell it, sort of pretend like you do, and it'll still come up on Google search. Go on there, and there's a video that says how to do everything. How to set up an account, how to figure out where your house is, and when you set up your account, it's going to ask you to put in like your GPS coordinates you can get off your phone. You'll submit that to the state, and somebody on John's staff will approve it, and then they'll lock you into the location. So therefore, anytime you record your rain, it's there. There's instructions on how to mount it. I've got mine out in an open area. I've got it on a wood 4x4 post. It's about this high off the ground. And it's got a mounting bracket. You just screw it on the side, and that thing comes off and goes back on, and it tells you how to measure rain. What happens if, like last year, we actually got snow, and it clogs up the top of your little phone. It'll tell you how to say, I observed snow. You know, that kind of stuff. So, yes.
And is there somewhere that explains us how we report that time?
Yeah, somewhere means that when you get on DMS and you do volunteer hours, this would be under field research. So when you get down to the columns, it's in like direct outreach, public outreach. This is under FR, field research. It says CoCoRaHS. You go do your monthly recordings, like you just basically a screen comes up, you hit my data, and the base screen comes up from this morning, and it says, what do you see at 8 o'clock in the morning? It's all hardwired, and it's already at 0, or you didn't get rain overnight, just hit submit, done. If you actually had some rain, you have to walk out there and see it's 2. Like in this big rainstorm a week ago, I had 2.48 inches in my house, south of me. And when you do that, you can look at a static and an active map, and you can look at the counties and sites all around here, and you can say, oh, just east of here it rained 3 inches, just north of here it rained 1 inch. You can actually see where the front's train over.
What happens if you miss it?
Nothing. And in fact, what if you're on vacation? There's a mechanism in there that says, I can go out here after I've been in Colorado skiing, and I look at my rain gauge, and it's got 2 inches of rain. I say between this date and that date, I got 2 inches, and that goes into their database.
Okay.
Okay, and Scott, if they forget that this is field research, this appears in the bulletin. It's one of those ongoing things,
Yeah.
right? So you can always look in the bulletin for what letters you use to record your 2 hours. And you just do the 2 hours one time a month.
Yeah.
Right, you
So
don't do it every
after you do your month,
Yeah.
just go in there and put in 2.0 hours of recorded data for the month. So that's your 2 hours a month, but it's actually sort of fun, and you get to see how much rain is going on around a multi-county area.
Okay, and then I had people that wanted to get one but didn't have cash or a check on them. And I said, oh, I'll just bring them next time. And Scott said, why don't you just let them take one and tell them to give Carol $35 and we'll just be on the honor system. And you know what? That totally works for me. So anybody else that wants one?
Yeah, just
we can
go,
make that happen.
write your name, like there's a sign-up sheet, that's Bobby's sign-up sheet.
Yeah.
Bobby is your mentor in waiting and back. And just write your name, and then at the next chapter meeting, which you're in person now,
Yeah.
Go to the chapter meeting, see the presentation, and just get Carolyn a copy.
$32, my bad, sorry.
Yeah, everything about what we do is on the honor system anyway. Nobody can say, I did my 2 hours of rain gauge stuff. It's on the honor system. So
You come out and help us install it, right?
for a minimal fee, and an old retired guy on fixed income, I need money, so I can work for beer or something appropriate in payment. So with all that being said, now we're gonna turn it over to John Ferguson, who is, at least as far as I am concerned, world famous. He's gonna tell you about Nature's Way. If you haven't heard of Nature Way's resources, this is the man that started it up. This is the guy that shows up on Randy Lemon's garden show and all the other garden shows. And so therefore, now you've met another famous guy besides Dr. Neil-Gammon. I can't say John's last name. But anyway, this could be, and I'm gonna rat you out, he could be retiring. And if he does, this could be the very last presentation you'll see from this gentleman, and he's the man. So take good notes.
Yeah, well, thank you. Well, like I said, I'm John Ferguson. I own Nature's Way Resources. I'm a licensed soil scientist. That's what PG means, professional geoscientist.
John, I'm gonna go over here and make sure that the Zoom people can hear us.
Okay.
Yeah,
I need to stay closer.
the microphone's right there.
Okay, that's what I thought. So anyway, the story begins back when I was in grad school. I wanted to be a PhD physicist, and I had an old-fashioned professor. He wouldn't let me write a negative thesis, so I had to keep taking courses. So I ended up with multiple degrees in chemistry, math, physics, geology at the undergraduate and graduate level. And after about 8 years of grad school, I said, enough. So anyway, well, a series of events. About 40 years ago, I was putting a vegetable garden in my backyard. And conventional wisdom of the time says you take a fungicide called cactan, you dust your potato eyes with it. They won't rot in the ground. You get more plants, more potatoes. Well, that's what I was taught in college. Washed up afterward, next morning, couldn't bend my fingers, could barely breathe, couldn't open my eyes. My wife rushed me to the hospital, and the doctor said I came in for 2 hours, losing my life. It took me 6 months to recover. And being a scientist, I started researching it and found that 35,000 people a year die from cactan exposure, and that was acceptable risk in EPA guidelines. And I said, to that. It gave me a passion. My wife was called obsession to study environmental issues and environmental things. And having this technical background, one thing led to another, and that's how I started Nature's Way Resources. We recycle organic waste, people good composted mulch soils, so they didn't have to use toxic chemicals. So I've been asked to talk to you about soil biology and modern methods in horticulture. So put this slide here since I knew I was following John, the climatologist. This is back during the freeze a couple of years ago. You notice, whoops, there's the laser. The yards over here and over here had snow on them. But this yard had very little snow. Why? This was an organic yard, had lots of organic matter, and the microbes were eating the carbon in the soil, releasing energy. And if you think about how we burn wood in the fireplace, carbon in the wood combines with oxygen, gives off energy in the form of heat and light. We all know that. Well, when we put carbon in the soil, microbes combine it by using biology, the carbon and oxygen, the same amount of energy is given off. But it just shows how much warmer the soil was. That warmer soil protected the roots and other life in the soil. So just a simple example. In the talk today, about 25 years ago, soil scientists started developing a new model of soil fertility called the soil food web. And a couple things, having a nursery and a garden center and a soil yard, one of the biggest problems, people come in all the time, and their problems in the yard started with soil. They had bad soil, bottom line. And I remember this old comment when I was growing up. Dewey Compton, it's far, far cheaper to put a $1 plant in a $10 hole than a $10 plant in a $1 hole. But 95% of the time, people do the opposite. And then wonder why the plant has insect or disease problems, or why it's not producing fruit or flowers. So, okay. Let me see if I can get this off.
there.
There we go.
Thank you.
So anyway. And the other thing is insect and disease. People, we get healthy soil. A lot of our insect and disease problems we see in our yards and gardens goes away. So, okay. Okay, Scott around. Yeah, when I admitted somebody and froze up again. Well, anyway, we're learning in soil science that healthy, fertile soils, there's microbes in there that prevent disease. We get disease when something's out of balance. So we have to start looking and asking ourselves, why? How did it get out of balance? You know, you look into a forest, massive productive ecosystems, no disease, no pest problems. Hey, there he goes. So it deals with the microbes in the soil. And I'd love to start with this little cartoon. What is the difference between soil and dirt? Oh, come on now. Y'all are supposed to be.
I think soil is alive.
Excellent. Soil's alive. You go out into the forest or the prairies, you dig up a handful of soil, there could be 6 trillion microbes in it. But if you go to our yards and gardens, many of our agriculture fields, what we had was dirt. There's hardly any microbes in it. So, and that's the USDA started educating people about it years ago. But in soil science, we started looking at our natural soils, no disease, no pest problems, lots of productivity. They can withstand floods, drought. We had one set of conditions. When we look at our soils in our yards and gardens, they were just the opposite. Okay, how to get this off? At least that's minimized it. So we had to start asking ourselves, why? Why are you seeing such huge differences? Well, okay, Scott. Yeah, it's froze up again.
Did it again?
Yeah. There we go. So we started looking at USDA data. And over time, as we've applied more pesticides, the amount of insect problems have increased. As we've used more herbicides, the weed problems, more fungicides, more diseases. The chemicals are not working. And all the problems we're seeing in society and horticulture has been steadily increasing. If you look at this slide, again, USDA data from 1900 up to about 1948 or so, there wasn't many change in the insect disease weed problems, and all of a sudden they spiked. Anybody have a clue why?
DDT.
You're warm. What?
The insects in the
Nope.
water.
Monsanto.
What event? Everybody remember the Oklahoma City bombing a few years ago?
Yeah,
What were the explosives?
fertilizer.
What event was over in the 40s? World War II. I got $1 billion factory to make bombs. No one's buying bombs anymore. What can I do with it? I'll make artificial fertilizers. They became available, became cheap. We used them, and the problem shot off the scale. And since, John was talking about climate change, one of the newest models of climate change, one of the biggest factors possibly causing more climate change than the oil industry and gas, burning fossil fuels, is the fertilizer industry. One, it takes a lot of hydrocarbons to make the fertilizer. It takes a tremendous amount of energy, burning coal or whatever, to make it. And then we put it in our soils, and it creates ammonia, which is 27 times, or a molecule of ammonia, 27 times worse than a molecule of CO2, and nitrous oxides from water-soluble nitrogen that's 300 times worse. That the total impact from using artificial fertilizers in climate change may be greater than the fossil fuel industry itself. So we're having to rethink things. My wife's a psychologist. This is an old slide, 30 years ago. But at that time, we went from 6 million mentally retarded in the United States to almost 10 million. from 6 million Einsteins to less than 2. This is 30 years ago, and it's continued to drop. 30 years ago, autism was not in a factor, but today it is. Men's sperm counts have dropped over 50% in the last 30, 40 years. We had to keep asking ourselves why. We look at nutrition density of our food. According to the USDA data, it's plummeted. Out of the top 100 industrialized countries, the quality of our food in the United States is now 98. Many third world countries have better quality food than we do. Other data we look at, again, we start looking when we started doing things, how the nutrition levels. So when we started tilling the soil, what does tilling affect? Well, it kills fungi in the soil. Fungi help plants absorb nutrients. Then we started using ammonium nitrate. Ammonium nitrate's a salt. Why do we put salts in canned goods, potted meat? Kill microbes. Microbes help plants absorb it, so forth. That leads to the problems. Other things. Again, an old slide. At this time, it was 26 apples to get nutrition one apple had in 1950. Today, it's almost 40 apples. We get calories that make us fat, but we're not getting nutrients. So we have a system that's just totally screwed up. At the same time as the elements in the soil, the minerals went down, all these other problems shot up. So we have to change the system. So that's why we started looking at other things. Another one, how the things. Well, one of the biggest kickers is Roundup. You probably didn't see it, but MIT did a bunch of studies on COVID and found out eating foods with Roundup on it was one of the single biggest causes. It was a 0.99 correlation. Russian roulette's only a point being dangerous, only 0.16. Well, the original patent for Roundup glyphosate was a pipe descale. You could put it through a pipe that's clogged up with calcium magnesium scale, and it cleaned it off the walls of the pipe. Well, for the human immune system to work, you ought to add calcium, magnesium, and to a lesser degree, zinc, chromium, and selenium. When you eat foods with Roundup on it, your body cannot absorb those nutrients. And we saw from the previous slide, there wasn't much of the food to begin with. So I think COVID was actually a food problem, nutrition problem. Many researchers now. So other things. Again, remember, Russian roulette's only 0.16. So the other thing is associated with exposure to Roundup, glyphosate. That's kind of scary, isn't it? And yet it's still so restores. Of course, it's known by a lot of people, the Enhanced Profit Agency. And as I said, the fungicide that almost killed me, kills 35,000 people a year, and it's acceptable risk in the EPA guidelines. It's acceptable to food. So the money to get kickback from the chemical companies. Other problems. Oops. We have a dead zone. In Mississippi, these chemicals, water soluble, end up in the bio. Fish can't live in it. We've destroyed fisheries. Around the world, there's almost 400 of these now. We've lost enough protein to feed over 2 billion people a year from our fisheries because of the chemical runoff. They say you got to have these chemicals to feed the world. If you take off the negative, we're actually losing productivity. So then, of course, you have the CO2 John already talked about. It's estimated as much as 60, 70% of our, 60, 70% of our CO2 came out of our soils. Before we started tilling, we had about 8% by weight organic matter in the soils, which is about 25% by volume. Today, through most of the United States, to use an example, it's less than 0.5%. So where did that organic and all those carbon go? We got the artificial fertilizers fuel the bacteria that release this carbon dioxide. And it's getting so bad in parts of the country that soils will not drain. They're having to put in like perforated pipe, French drain pipe in the fields and get it to drain. And there's no nutrients. So we develop hybridized crops that can grow a nutrient depleted soil. So we got to change how we're going to do it. So the cost, I won't go over it, but it's critical causing this one. This slide was done long before COVID. So we got to change how we're doing it. So the new model is based on study in nature. In nature, energy from the sun. Through photosynthesis, plants capture that energy, form carbon compounds, carbohydrates, proteins, amino acids. The plants then provide organic matter that feed the bacteria and fungus. The bacteria and fungi feed protozoa, nematodes, so forth, eventually birds, animals, and mankind. So it all starts, that energy from the sun gets captured by plants and starts the food web. Well, we call it a food web. So as we have our first stage decomposers of the organic matter, they get eaten by the second, third group, so forth. But the fecal material here comes all the way back here. In nature, it's a perfect recycling system. Nothing is wasted. So what we want to do is, the closer we can capture this in our yards and our gardens, the better. Yes, sir.
So we say we have to change our ways, but how are you going to get the general public to endorse this?
Well, it's happening all over the world. The organic sector is the fastest growing sector of horticulture and agriculture worldwide. Several countries have already made comments to go totally organic in their agriculture and outlaw chemicals. We're seeing it occur. Just the United States, because of corruption basically in our government, is probably half. Yeah.
To add further comment to that, I'm gonna speak up for the speaker. I quit using synthetic fertilizers and went to organic because of a presentation I saw him give 4 years ago. You hear John on all kinds of garden shows, and you have competing do this fertilizer schedule, and after listening to him, I stopped doing it. So that's a small example, but there's a bigger example in some of the courses that you're going to get over the course of your training. There's conferences and societies that advocate, even all the way up to Nebraska and Iowa, about organic farming or putting in buffers around these zones, putting in pollinators and filter water, and all of that ties directly into the information that he's conveying. So it's not just local, it's a big deal. The Xerxes Society is one of them.
Yeah, I understand that, but I guess I still feel that there's a small percentage of people that are trying to do the right thing, particularly when you're fighting the agricultural industry, which is supportive of the circle of more fertilizer, pesticides, herbicides. And I know they've done some things to try to reduce what they're using for the cost benefit, but.
Well, right now, economics is driving it. It's so much cheaper to use the natural methods of biologicals. Own yard, it's been in Better Homes and Garden. I haven't had to water my flower beds or lawns since the drought of 2011. Saved a couple $1,000s a year on my water bill. I use 1 bag of organic fertilizer every other year now. It doesn't run off. When you use an artificial fertilizer, 70–80% of it ends up in the biles and streams. Creates a algae bloom, sucks the oxygen out of the water, made a breeding ground for mosquitoes. So you can see these hidden costs all through society. So we got in Houston 40, 50 large properties I'm aware of that are totally organic now. Anything like the Royal Herman Hospital system. How would you want a patient who's got a weakened immune system to be exposed to diazinon or one of the pesticides? Shangri-La Botanical Gardens in Orange used to struggle with all the saltwater intrusion and salts in the soil there until they went to organic. Then the microbes released the salt, and their operational costs plummeted. Now it's a beautiful, landscape garden. There's hundreds, if not thousands, of examples. Gabe Brown up in South Dakota, making full crops of corn and wheat on 15 inches of water a year, which according to the USDA was impossible. So we're seeing examples all over the world where it's working. We'll get more into detail. So anyway, we got everything's recycled in nature. And if we get this soil biology working, the bacteria, the fungus, the protozoas, and nematodes, we get major benefits. We get disease suppression. A lot of the good microbes compete for the same food as the bad guys, so the bad guys starve to death. Some of them put out chemicals. We're familiar with penicillin, prevent the bad guys from growing. Thirdly, a lot of the good guys eat the bad guys. No one's ever developed resistance to being eaten. It's 100% failure. It's the nutrients that the microbes store the nutrients in the soil. They break clay apart, make the nutrients available. They create soil structure. They break down the toxic stuff, plant hormones, and improve the crop quality, flavor, nutrients, yield. And the story I love to share is, back when I was in college, Gallo wines was kind of a cheap wine to have a party with. And about 10, 12 years ago, Gallo started winning awards some of the best wines in the world. And they finally admitted those were organically grown grapes fertilized with compost. And what they discovered, there's a species of fungus that colonized the grape root. And it was actually the fungus that produced chemicals called isoflavonoids that would then be absorbed into the plant and gave the grape its better flavor. These are also the same things that are anti-cancer compounds. So if you raise a plant with fungicide, you kill off the fungus that produces the anti-cancer compounds. So we no longer have in our food supply. So you got something like Roundup that causes cancer, it's been well documented now, and we're losing the stuff that prevents it. We wonder why cancer rates are soaring. So getting back to the model, when we start looking at natural soils, like we go out in the desert and look at the soils, you might have some bacteria in the soil, some photosynthetic algae, but it's not a very productive soil, is it? You go to grasslands, we start getting some fungus showing up. Shrublands, you start getting nematodes and earthworms. And finally, we get to the rainforest, which is ironically the most productive ecosystems on Earth, yet they're growing in some of the most poorest quality soils on Earth. All about the biology. So we have this model, what we call a fungus to bacteria ratio. We can measure, well, we observe weeds like soils that are high in nitrates. Well, what's an artificial fertilizer? When you use it, you select for weeds over perennial plants. They like soils low in oxygen. You start looking at early grass like Bermuda, all of a sudden you get some fungus show up. Mid grasses like St. Augustine, almost equal amounts of bacteria and fungus in the soil. And so forth. Shrubs, vines, 2 or 3 times, 5 times more fungus and bacteria. Fruit trees, maybe 30, 40 times. Finally, old growth forest might have 1,000 times more fungus in the soil than bacteria.
Which is a good thing.
Yeah, for most things, unless you want to grow a weed.
Okay, thanks.
So even the type mulches we put, do we put a mulch on our beds that encourages bacteria, or do we put one that encourages fungi? So we determine a lot of our problems, but we can use this and look at it. So what changes that model? You know, what pushes it? Do we push something back here to a problem we have less problems, or do we push it back to a system with more problems? Well, we call these disturbances. Genetically engineered, air pollution. Everybody remembers the acid rain up in New England a number of years ago? Yes, ma'am.
I have a question. So, for instance, on my property, I've had a terrible problem with the sting nettle.
Uh-huh.
And it's like within the last couple of years, it just keeps multiplying crazy. And I don't want my granddaughter getting into it when she's out in the yard. So when you have a person that has something in their yard like that they want to get rid of, but you don't want them, you know, or they don't want to use a spray to kill it, what kind of things do you suggest to people to get rid of the problem if you don't want to use some bad spray?
Most of the time, the plant species we call weeds are trying to correct a soil problem. For example, the dandelion. It's an annual, has a deep taproot. It grows on soils that are low in oxygen, compacted, and soils that are low in available calcium. So if we look at dandelion's role in nature, that deep taproot goes down into the subsoil, collects calcium atoms, brings it up into their leaf tissue, and when it dies, it rots, that calcium is released. When you get the correct amount of available calcium in the topsoil, the seed won't even germinate. It's done its job in nature. At the same time, that deep taproot, when it rots, you create a channel for air and water, addressing the compaction. There's books up there, Weeds and What They Tell, Weeds as Diagnostic Tools. And I remember reading somewhere years ago, I haven't had stinging nettles, but it's caused by something in the soil being out of balance that it's trying to fix.
So you change your soil and then
it will go away because it's trying to do something in your soil. So that's the natural way. And there was a lady just passed away last month, Betsy Ross at Sustainable Growth. She was an expert at using weeds as diagnostic tools and how to fix it. Finally, she was in her 80s, finally passed away. Anyway, things that change it, fertilizers, pesticides, herbicides, more crop, organic matter. Some organic matter can cause weed problems, other organic matter gets rid of them. So all these things changes the soil biology. So we take this slide, do we put it here to a mature system that has less weeds? Or do we have an immature system that favors weeds? Well, the species of plants, most annual plants are bacterial lovers, and that's what most of our annual weeds are. Most perennials are fungal lovers. They want 100,000 times more fungus in the soil. So we can start understanding what plants want. Particularly if you got to a prairie or a forest, that's heavily fungal dominated soils. If you ever notice that when the fire ants typically grow right on the edge of the forest, they don't like high fungal conditions. They like soils with lots of bacteria because the fungus eats their eggs. So they don't go into high fungal areas, or it's less common, I should say. You'll find exceptions to everything. So, oh, thank you. So anyway, remember after Hurricane Ike, flooded a large section of the Gulf Coast. What were the first plant species to come back and rebloom? The weeds. See, all that salt water killed off the fungus in the soil, left in a bacterial situation. After Mount St. Helens blew a while back, what were the first? The annuals. They come in, the bacteria grow, they create some organic matter, then after a few years, you grow fungus, then you start getting upper, higher level species. So we can determine, we can push it back this way, or we can do things that pushes it to a more mature system. So, apologize for coughing, but that fat cat can exposure left me chemical sensitive. There's some chemical in the air that's triggering an allergic reaction. I'm the canary in the coal mine for toxic chemicals. So, well, one of the myths, Dr. Lane Ingham up at Oregon State years ago when she was there, started studying, you've probably seen in gardening textbooks, oh, if you want to grow seeds, you need sterile soil. Well, she could never find a single reference in the scientific literature that was true. So they measured soil with just bacteria and plant growth. Add a few nematodes, plant growth increased. We got thousands of microbes together. So, this is a picture of a root hair. Can anybody tell me what's missing? What?
The plant.
Well, it's the root of the plant. What?
The hairs.
Well, this is the root hairs. It's blown up 1,000 times. So it's missing fungus, mycorrhizal fungus. Over 90% of all plants on Earth live in a symbiotic relationship with the microbes and the fungus in the soil. And what happens is mycorrhizal fungus coats that root hair. So if a root-feeding nematode or another pest comes by, they never see that tender root tip to eat because there's an armor of fungus protecting it. So, pretty cool how nature works. Oh, but I put a fungicide on my rose bushes and it rained. Sprinklers came on. Goes into the soil, you knock that guy off. You wonder why you get a root rot or a root-feeding nematode problem. We do it to ourselves. But this is an example of electron microscope. You can see the root tip growing and you can see the cells of the fungus growing with it. Very powerful relationship. This is just a pine seedling. You know, pines are considered pioneer plants. They grow on poor soils. That's why you see a lot of pines around here, because we've got a lot of sandy soils that are relatively low in nutrients. And here you can see the taproot starting to form and a couple little spurs. These white clumps of nitrogen-fixing bacteria. The rest of this is fungal mycelium. Mycorrhizal fungi. They have expanded that root zone 10,000 times to get like water and nutrients for that seedling to survive. So it's one of the things, I never plant a plant anymore unless I put some mycorrhizal fungi spores on the root ball when I plant it to help it get established. And I'll show some more examples in a minute. University of Alabama study, they took some sand, put a pine seedling in it, both 1 week old, with no fungus, with fungus in 1 week. Pretty strong effects. You know, who wants to use pure sand as a growing media anyway? but it shows how they help the plant. Field crop. This is done conventionally. This was an organic system with the fungus and bacteria and microbes. If this is a fruit tree, which one do you think is going to produce more fruit? Excuse me, yeah. If it's a blooming plant, larger flowers, more flowers, withstand a drought or flood, wind, yeah, the one's the better root system. Many of the microbes produce plant growth hormones, and it's kind of a feedback loop. So, a few years ago, I co-authored a book called Organic Management for Professionals with Dr. Mike Amaranthus, a microbiologist. This is one of his slides. This is out in Southern California, very salty, saline soils and stuff. In this orchard, what they did, it transplanted, these were planted, both sides were planted at the same time. These had been inoculated with mycorrhizal fungus. These were not. 3 years later. This is a lemon orchard. These trees were already in production. So that $1.50 a plant they used for putting mycorrhizal fungus, is it worth it? Yeah, it's going to take 20 years before these, grow big enough to start producing. So it shows how powerful the economic effects that using these modern methods can be. And fungus do a lot of other things, and don't have time to go into it all, but then we got the bacteria. Many bacteria can fix nitrogen. We've learned that even algae can fix nitrogen on the surface of salt, if and only if the trace element molybdenum is present, which is a catalyst. So that's one of the benefits of remineralizing soils. Get these trace elements back in the soil, let the plant decide what it needs. So here's where it kind of starts, to me, gets interesting. This is an electron microscope of a root. You can see some bacteria starting to colonize it. And here, you notice here, you can see the root here, all this stuff here. The root is dumping stuff into the soil. What we've learned, depending on the species of plant, anywhere from 60 to 70% of all the energy, the chemicals from photosynthesis, the amino acids, the proteins, the vitamins, the sugars, the plant dumps into the soil. Man, are plants stupid or something? If you gave away half your paycheck every month, do you expect something in return? Hey, if not, I'm getting ready to retire. I'll take donations. Yeah, this is to feed the microbes they want. Because the microbes protect them from disease. Microbes help collect nutrients. They're paying the microbes to go to work for them. So, this is courtesy of one of my landscape customers. This is on St. Augustine grass. And he was using organic techniques, the modern techniques. Notice the mycorrhizal fungus colonizing the tip of this grass. Out of curiosity, how deep will a St. Augustine root grow? 1 inch? What? Any other? Yeah, how deep in the soil can it genetic potential to go? How much? Not deep. The University of Florida has measured St. Augustine roots 12 feet. As I mentioned, I got a retirement place up near LaGrange, and some St. Augustine escaped into the field. We've had 2 years, or a couple years ago, drought less than 15 inches a year, and it's thrived. Well, St. Augustine's a hybrid grass between a prairie grass from Africa that has roots that go down 15, 18 feet, and a Gulf Coast species that's humidity moisture tolerant. So it has the genetic potential. So why don't the roots go down? Compaction, lack of oxygen. If the oxygen levels of soil get below 6 parts per million, roots can't live. So what things causes compaction? We'll get there. So water. Under traditional soil science, from sand to clay, the blue area is how much water is held. Through chemistry and physics, this dark blue area is available to plants. However, if you've got biology, you've got the mycorrhizal fungus, they can collect the rest of this water, which gives you 2.5 times more water available to your plant. That's another reason you don't have to, the drought or have to water as often. So, Well, if we look at historical data, now remember 8% is what the Great Plains had before we tilled it and ruined it. But if we only have 3% organic matter by weight, 60% porosity, air, water, that means we can hold 120,000 gallons of water in the top 18 inches. So in a great topsoil can have 8% by weight, which is about 25% volume. It was estimated, I did some work a number of years ago with one of the major landscape architects here. He had some good data from the city of Houston about if only 20% of the turf in the Houston area used organic techniques, it would have dropped the flood waters of Hurricane Harvey 40%. We would not have had a flood. 20%. Again, we do it to ourselves. So, compaction. What causes compaction? This is kind of an interesting slide. Just a 7% increase in compaction would cost a 98% reduction in water getting into the soil. What causes compaction? Tilling, because that destroys the soil structure, closes off the pores that water can soak through. Tilling kills earthworms. Earthworm tunnels lets water into the soil. What about fertilizers? Anybody ever leave a pair of pliers out in the yard in the rain and dew for a few weeks? What happens to it? Rust, freezes up. Because rust is a salt. What are all artificial fertilizers? Chemically salts. They go in, they glue the soil particles together, creating hard panning. So that's another devastating fact of the artificials. So without air and water, roots can't go down. Other thing, when we start looking at soil temperatures, you know, John talked about it previously, but how does it affect plants? If the soil temperature is only 70 degrees, 100% of the moisture in the soil is used for plant growth. If the soil goes up to 100 degrees, only 15% of moisture is used for growth, 85% is to cool the plant. So that's why it's so important to mulch soil, mulch our flower beds. Yes, ma'am.
What I don't understand is why on the side of the road, when nobody does anything at all to the soil, and the soil is just there, wildflowers grow like crazy. Nobody does anything to them.
That's the whole point. That's soil's full of microbes. It's not disturbed.
There's no.
Like bluebonnets fix nitrogen. See, they're responding to low nitrogen in the soil. And if you actually correct the nitrogen levels, the seed won't germinate. So each plant has a purpose in nature. And that's part of our job as modern gardeners. We got to figure out, what does that plant do in nature?
But they grow like the worst soil possible. Like on the side of the road, there's like sand, there's no
Exactly.
water.
Where do those plants grow in nature?
I mean, I want to grow, but I can't.
They like bad soil. Their job in nature is to fix the soil problems.
My question is gonna be about mulch, because I'm getting the message. Will you at some point address, like, should I be picking up the pine needles and the oak leaves, digging them down, and what's the best mulch? So when you get around to it, address.
I have a whole separate talk just on mulches.
Okay.
I've been working on a book. I've got 400 pages written on mulches. And a book I hope to publish when I retire. I get time to finish. But quick, the native mulch is the best type of mulch. And I can go into that later. But any organic material improves soil. So pine straw, leaves help. How does nature mulch the forest? The more we copy nature, the less problems we have in general. So is this clear, everybody? That's important. That's why top dressing along with compost, leaving a half-inch mulch or thatch layer in there, because acts as mulch, insulates the soil, keeps the soil temperatures down. There's a test garden over in the Woodlands that they haven't watered since the drought of 2011. I've met, you know, one of the people at the Houston Botanic Garden, they haven't watered since 2011. So we can do this, and that mitigates against climate change and excesses, but the chemical industry is so profitable that we'll get there. So,
Something that I've noticed with my mulching is, like, I'll do live mulch, so they're like sweet potatoes or something, right? Great. But if I ever use like leaves and things, I always have such an insane amount of snails. It's keeping the soil great, but then they're eating all my plants.
Yes, snails like moist condition.
Yeah, do you have a,
What I do in my own yard and garden every other year, I get a couple of baby ducks from the local store.
No, really?
They love snails. They'll stick their beaks in every crack corner and they eat every snail slug in my yard. I don't have to worry about them for 2 or 3 years.
Can you rent a snail? I mean,
I buy the babies $2 a piece.
and then what?
When they get big, they fly over the fence.
John, for the people that are online, can you repeat the question?
Oh.
Yes. Thanks.
The question was, how do I get rid of snails? And like I said, one thing, there's products like Sluggo, it's iron phosphate, primary nutrients that'll kill them. But again, if you get a healthy ecosystem, there's enough animals, insects that eat snails that keep the population at low levels.
okay, thank you.
So, okay, let's move on to protozoa. This is one guy, he lives in the water films around thing. You can see the little tail that he flips, and that's how he swims. Why is this guy important? Remember one of the early slides I said the 7 benefits that microbes recycle nutrients? When we start studying nature, well, bacteria have 5 carbon atoms to 1 nitrogen. They're the most nitrogen-rich life form on Earth. Fungi are about 20 to 1, people are 30 to 1, green leaves 30 to 1, protozoa, snakes, fish, snails, birds are all 30 to 1, nematodes, ground plant material, deciduous wood, conifer wood, bark's about 700 to 1. Researchers gone all over the world, soils that are healthy, fertile, productive, have a 30 to 1 carbon nitrogen ratio. It's a constant we see all through nature. So we desire 30 to 1. Well, this guy, protozoa, have a 30 to 1 carbon nitrogen ratio. So when this guy eats a bacteria, he comes in, eats his bacteria, he's picked up 5 carbon atoms and 1 nitrogen. That protozoa to grow and reproduce, what does he have to do? Eat some more bacteria. So he eats 6 bacteria. He's got his 30 carbons, but he's got 6 nitrogen atoms, but he only needed 1 nitrogen. So what does he do with those extra 5 nitrogen atoms? He excretes them. He poops it out. Where's the bacteria density? Right, highest, right next to the root hair, where the exudates are feeding the bacteria. So either the fungus or the plant can just suck it right up. Doesn't pollute our waterways or anything. It's not wasted. Perfect recycling. So, does a bacteria like to get eaten? I wouldn't think. I can always imagine, a big lion coming at me. I don't think it'd be a pleasant process. So how does a bacteria protect itself? Well, many of our soils are full of clay. And clay are like sheets here. You can see in this diagram. There's silicate minerals, quartz minerals. Quartz is pretty hard, tough stuff. So what a bacteria does, puts out an enzyme to glue these clay particles, the quartz minerals, around it to make an armor of quartz. Now he can't get eaten by the protozoa or the nematode. You've created your first microaggregate of soil structure. Later on, fungi type these microaggregates together and create what we call a PED in soil, a little unit subsoil thing. And you create big pores between the PEDs that air and water can go in the soil. And we're starting to build a healthy soil. So, and I'll pass this around for the people here. This is what, Lake Charles Beaumont clay. Oh, good. This is about 15 months apart.
I'll be back.
So as the bacteria produces this, it breaks the clay apart, and over time you can take a heavy clay and turn it to a beautiful loam. Yes, sir.
It says 15 months. You're saying that in 15 months you can go from a highly compacted soil to a
Correct. In this particular example, put about 5, particularly this is done with certain type of mulch that feeds microbes that break clay apart. So you put 4 or 5 inches of mulch, a year later, 2/3 of it's decomposed, You now have 1-2 inches of clay is broken down. You do it again next year, you keep going down. Like in my yard, I've been there 40 years, it's broken down 3 feet in most spots. That's why when it rains, I get 3 inches of rain, it just soaks in. It's held in the soil if I need it, so I don't have to water. Okay, any other questions at this point? All right. How many people have St. Augustine grass? The majority of people. You ever get brown patch? Take all St. Augustine decline. About everybody, okay? Why? Well, it turns out there's a good bacteria, chain-forming bacteria called Actinomycetes, lives in healthy soil. This guy's favorite food is the Rhizoctonia solani that we know as brown patch, or the other pathogens known as that. He eats those pathogenic fungi. If you've got this guy in your soil, you'll never get those diseases. Let's work backwards. Why don't we have this guy in our soil anymore? It occurs naturally. Well, you're getting warm. Why do we put salt in canned goods, potted meats, jerky? Because it kills bacteria. He's a bacteria. What are artificial fertilizers? They're salts, chemically salts. So they kill this guy. And the fertilizer companies have known this for years. They'll make a 40% profit margin on the fertilizer. But now, gee, Mrs. Jones, you got brown patch. You need Terrachlor, Funginex, one of the broad spectrum fungicides. We got a 300% profit margin there. Well, healthy soil, a tablespoon of healthy soil may have 3,000 species of fungus in it. You kill them all off. It's like going to a Texans game. You got 85,000 people, one criminal. Oh, we better kill everybody. Sound reasonable? I can't believe we believe this garbage we were fed by the chemical company. Okay, you kill off the fungus. Well, fungus breaks down thatch. So now you get a thatch buildup in your yard. What insect pests love to hide in thatch? Ever hear of wedworms, chinch bugs? You've created a home for them. Gee, Mrs. Jones, you got a chinch bug, a wedworm problem. Oh, you need some diazepam and Duraspan. We got 1,000% profit margin on those products. Yeah, it knocks it back. Kills your earthworms. Earthworms eat your weed seeds. Earthworm aerates your soil. Gee, Mrs. Jones, you got a compaction problem. You need to aerate your soil. You need to do core aeration. Oh, by the way, it's time for a weeding feed. They keep us on this merry-go-round. They figure if we're stupid enough to fall for it, they'll continue to take our money. So, and these are things we've learned over the last 20 years. So, okay, well, the converse, what else do you think kills this guy besides salts? Why do we put chlorine, chloramine, fluoride in water systems? To kill bacteria. So the more you water your yard, the more of these good microbes you kill, the more you're setting yourself up for disease problems. Okay, moving on. By the way, where can you get this guy? Oh, excuse me.
So would you recommend filtering the water to water your yard or just using rainwater instead?
Rainwater is the best because it has dissolved nitrogen in it. You can filter it. Like in my case, I've worked on soil improvement the last 40 years. I don't have to water. So that's the ideal case. But yeah, you can filter it. They make hose-in sprayers. You go on your hose that filters out the chlorine thing. I use one when I have a fish pond in my backyard because since fish are very sensitive to chloramine, it filters it out before I put it in. So there's things you can do. Okay, where can you get this guy? A good, properly made compost is full of it. So that's one of the reasons why a good compost, like leasehold compost, if made properly, is very effective at controlling all the yard diseases, the brown patch, the take all, the St. Augustine decline, because it's full of this microbe. Other things. Let's see. Talk about salts. We're on the Gulf Coast. We got part of our oil industry here is salt domes that push up near the surface. They create fault zones. Groundwater gets in, dissolves the salt. you know, we get salt to come in on tropical storms like Hurricane Ike. They measured salt from the Gulf of Mexico up in Tetra counties. So many of our soils are on the edge of sodium toxicity. And if you get up around Bryan College stations, many plants can't even grow up there because there's so much salt in the soil. So researchers started looking at, one of the things sodium does, you can hold ions or nutrients in the soil. If you've got lots of sodium, it prevents the good nutrients from being in the soil. Doesn't change pH. So, and when the sodium's there, it throws things, the calcium magnesium ratios out of balance, creates hard pain, compaction again. So, but here's an example of salt damage. Looks very much like a disease problem. So in this case, the guy had a water softener that uses sodium to exchange. That salt water is what he's irrigating his yard with. So, anybody remember this old commercial? There's some of us old enough to. You know, used to advertise put it on your patios and stuff, in your brick walkways to kill the weeds. Salt kills plants. Yet artificial fertilizers are salts. Another example. I've mentioned efficiency in water use several times. This is a special membrane that does not let the sodium chloride ions pass. When no salt is in the water, the roots go right through it. When there's salt in the water, the roots can sense the presence of it. It's what we call quorum sensing. And the roots turn away and won't go deep. Well, when we use artificial fertilizer or high salt products, they go down a few inches in the soil and they build up. Roots will not penetrate that layer. We do it to ourselves. Other things that salt does, takes a small, only 0.4% salt. You lose about 80% of the soil's water holding capability. We were talking about mulches. A colleague of mine, Randy Lemon, gave me this slide. The dyed mulches, good, bad, or otherwise. Some of the worst things you can do to your soil for your health. To get the dye to stick, you got to use raw wood, which is 500 to 1 carbon nitrogen. Healthy soil is 30 to 1. So when you put it down there, the first thing it does, the microbes try to break it down. They pull nutrients out of the root zone, stressing your plants. And they can eventually kill your plants. You know what the color to make it black is? Carbon black. It's a known carcinogen. You wonder why so many children and pets are getting cancer nowadays. They're about playing in this stuff. So, talk about economics. This is courtesy of one of my landscape customers a number of years ago. This yard went organic in January 2011. This yard used conventional chemical methods. After the first rain in mid-late September, they analyzed the cost. The total cost of this yard was $3,345. The organic yard cost us $773. Which yard was in better shape after the worst drought in history? Which one cost less? Yeah. So we can see the organics methods play good. Other things we're learning about the fungi, there's a lot of benefit fungi. We call them nematode trapping fungi. You can see the fungi growing, puts out loops, and it puts out chemicals that mimic the root exudates. So the nematode swims into that loop, the fungus contracts it, traps that nematode, then they put out enzymes and 5-HIB to digest it. There it's about gone. And you can see the fungal hyphae coming in. And so instead of that nematode eating your root, the fungi's capturing and they're digesting, so all the nutrients and water in his body is now being given to your plant. Oh, but I sprayed my trees for some mildew, fungicide. Well, you don't get this benefit. There's about 1,400 species of nematode. Only 20 are plant pests. The rest are beneficial. And some of them are predators. And they go around looking for the bad guys, sucking them up like a piece of spaghetti. But in nematodes are little worms. But why would you mind having it? Oh, I put down some diazepam and Duraspan. You kill these guys off. Now that's going to prevent the root rots. Turns out the pests are resistant. Other things. I'm going to run out of time. Whoops. Okay.
We're good.
Okay. Other things, so you've seen slides like this in Granbury where the bacteria, fungus, algae, like from lichens, and they start breaking down rock minerals. Just because we can't see them doesn't mean they're not working in our soils. This is a University of Georgia study where they took pea gravel and put soybean transplants in the pea gravel. They sterilized the pea gravel, had 0 microbes. Yeah, how many people use pea gravel as a potting medium? No one in their right mind, right? So no microbes, 100% chlorotic. The plant could not absorb a single nutrient. It was dead. But if we add more and more microbes, look at the plants are actually growing. The microbes are ripping that rock apart atom by atom, releasing the calcium, the nitrogen, the phosphorus in the rock. So just because we can't see them don't mean they're not working in our yards. Field crop, another University of Georgia study. This was in a sugar sand where they grow peanuts. They had a fungal disease in the soil, and they treated it with a commercial fungicide. This row, they treated it with a product called actinovate. If you might catch from the name, actinomycetes, the bacteria that eats fungi, bad fungi. Actinovate is a biological fungicide. Which one did a better job? Which ones would have bigger peanuts, more peanuts? Modern methods use nature to fight nature. So, what about earthworms? Good guy, bad guy? Yeah, sometimes called a gardener's best friend. So not only do earthworms aerate the soil, in their castings or tunnels, they produce a chemical called auxins. It's the most powerful plant growth hormone stimulator known to mankind. The other thing, so they line their tunnels and their castings and further. They put nitrogen and other elements in a form that plants can absorb. Makes it easy, so less energy required, less work. Other things they do, they eat weed seeds. And we used to think they eat organic matter. There's been a lot of research out of Ohio State, Dr. Clive Edwards, several hundred papers he's published in journals, that as soil particles pass through the earthworm's digestive system, old fat microbes, they're not producing much, can't work, they tend to eat and release all the nutrients stored in their body. So those nutrients come out in the cast. At the same time, the good microbes that prevent disease can increase 2 or 3 orders of magnitude. So it's a natural bioreactor increasing beneficial microbes in the soil. What do you think kills earthworms? So, yeah, I remember a trick I learned as a boy. I loved to fish. Dad had a big wash tub. I'd take a couple of triple 13, take my canoe paddle, dissolve it, pour it on the soil. The earthworms would come running out of the ground. I'd grab 50, 100 of them, wash and rinse them off so they wouldn't die. I was ready to go fishing in 5 minutes. Many times some buddies spent 2 hours digging worms. So yeah, salts kill them. Then there's your cast and stuff. What about grubs? Good guy or bad guy? Well, good. I got some hesitation now. Heard a good come in. Well, it depends. They're part of the natural cycle. They prefer to eat decaying organic matter. But if the organics matter has been destroyed by artificial fertilizers, guess what they eat? Roots. Just like I prefer a good sirloin steak, but if I'm starving, I'd eat dog food. It beats dying. Well, insects and plants are the same one. But what happens, say, by the way, the grubs too. You can think of earthworms as kind of like the air ducts in your house. The tunnels the grubs make are like the air ducts in this building. Big, lots of air and water move through the soil. So, but what if you got too close to, say, a rose bush that had the mycorrhizal fungus on it? Fungus paralyzed him, so instead of that grub eating the roots, he's now being digested and all the nutrients and water in his body are becoming plant food. And there he's about gone. Well, what about this guy? Isn't he cute? This guy. Yeah, these are microanthropods. Their job is when leaves fall, help shred it up, increases surface area so the bacteria and fungus can break it down and release the nutrients. God's nature is a marvelous system. And what about this cute little guy? You've probably seen him on the news. He's the guy sent to the space station that could live in space and vacuum and ultraviolet for months. without any protection. We got a lot to learn. Think about bullfrogs can jump. This guy, springtail, he can jump 100 times his body length. But what's interesting, there's been a lot of research. Notice he has antennas. For an insect that lives in the soil, why would he have antennas? Well, nature doesn't do anything without a reason. He can collect electromagnetic radiation that penetrates the soil. Dr. Philip Callahan wrote several books and hundreds of papers. He noticed that when soils are paramagnetic, that more energy went into the soil, and plants are more fruitful, more productive. So, very interesting. So paramagnetism just means in a magnetic field, something will go towards a magnet versus diamagnetic, it'll move away from the magnet. Just like kind of like conductors and insulators and electricity, property of matter. So then we got the millipedes, the centipedes, isopods. You know, he's another guy that has opportunities. He prefers decaying organic matter, but if not, he'll eat soft tissue. Oh, how did nature aerate heavy clay soils before man came in? Got any Cajuns in here? I'll give you a hint. Crawfish, very good. Yeah, crawfish tunnels, they can be as big around as a silver dollar, at least a quarter. They can go 12, 15 feet into the soil. So water, when it rained, could flow into the tunnels, then be absorbed horizontally as well as vertically. That's one of the reasons we're having so much flooding in South Houston, as we destroyed all those clay soils south of the Buffalo Bayou. There's no more crawfish, so the water piles up, can't go into the soil, so it goes into the bison, into the river streams, bayous, creates flooding. Well, here's another example in nature. This is an aphid. The soldier bug stabbed him, sucking his juices out, and the giant soldier bug stabbed him, sucking his juices out. Nature is a series of checks and balances, and as modern gardeners, we learn how to work with nature, copy nature. This slide was over 30 years ago. I was for my license, I got to continue education. And I was up in the northwest, or northeast actually, attending a soil conference up in Maryland at the USDA Vestal Maryland Research Center. Well, the year before, an organic farmer named Gary Logan won the National Corn Growing Championship. You know, all the ag guys were saying you can't feed the world using organic methods. He came in around 167 bushels an acre, and the national average was 130. He blew them out of the water. Not only was it higher yield, higher profit, had higher nutrient density, better quality. So they started saying, whoa, what is this guy doing? How can we copy it? So rock dust, minerals, compost. They had everything, sewage, hundreds of test plots. This is some of the very first research that led to this new model. Other things we're learning. This is Cestrum nocturnum, what's known as the night blooming jasmine. It's a plant very susceptible to cotton root rot when grown in pine bark or hardwood bark. When we plant it in native mulch, 100% disease control, because native mulch supported the beneficial microbes that prevented the diseases. So little things we're learning. This is a years ago test, little City of Houston tree giveaway, little 6-7 inch sapling from City of Houston. Guy never did anything in his yard or put it in, it wasn't growing, put in one bag of compost, watered it in. And by the way, one of our local universities tested it, said the compost was worthless. A week later, pretty strong response for something worthless, isn't it? Particularly, it was measuring water-soluble nitrogen. But where was the nitrogen in the compost? Bacteria, microbes, organic matter. When you put it on the soil, they start eating each other. Nitrogen released. That's a pretty strong nitrogen response. The only problem was the yard guy mowed the tree down. That's never happened, right? But 3 years later, I happened to be back by there. From that one bag of compost, it's about 6-7 foot across, still providing benefits. So, let's seed germination test. You've heard me mention 8% by weight or 25% by volume. Yeah.
I just wanted to ask, I noticed that the compost was just on top of that.
Mm-hmm.
Could you put compost just on top of your grass? Do you have to like mix it all in?
Well, if you get it fine screened, it tends to naturally filter in. Some people rake it, there's machines that blow it in. But the idea is you don't want to leave it on top, you don't want to smother the grass. And that again, that was before top dressing compost for disease control became popular. When I took that slide, it was just trying to show the nutrient benefits of compost. So, yes, sir.
When you go to a store, buy compost, what are you looking for? Organic compost or?
Well, yeah, if compost is made correctly, it's all organic. Texas does not have labeling laws. We got a guy over in Kingwood who grinds up railroad ties and sells it as compost.
Oh,
That's creosote, there's no carcinogen. Other people take sawdust, use carbon black to make it black, sell it as compost. Price points are the same. You know, good compost, demand's far greater than supply. So.
What about mushroom compost?
Not a true compost, spent mushroom substrate. To get the species of mushrooms they want, they dope it with sodium chloride, salt. It's so salty, nothing can live except the mushroom. There's diseases and stuff, they treat it with other chemicals to control the diseases. When there's not enough nutrients left to grow mushrooms, they have to get rid of it, spent mushroom substrate, and they sell it as compost since there's no labeling laws. A number of years ago, the journal Compost Science and Utilization had about 30 articles from all over the world on the problems caused by spent mushroom substrate. If you're on a sandy soil, you get rain, you can leach the salts out, you can get some positive results. The bad chemicals are still there, but you can get rid of the sodium. So it's you know, what are you willing to risk? So you have.
Is there any chance of the Texas legislature getting labeling laws?
Not too much money from the chemical companies.
Right. What about, just like rabbit?
It's good.
Just like, okay, and it's okay to include some of like the hay and things
Yeah.
like that?
Yeah.
And deer?
Yes.
Cow manure or something like that?
Okay, we're on the Gulf Coast. We've got a lot of salt problems. Cow manure is high in salt. That goes on, I mentioned poultry manure is another one high in salt. Poultry manure is also full of arsenic. That's why we've learned that it's been outlawed now, but they got 10 more years to phase it out. If you feed arsenic to a chicken, you can get them to market 12 weeks instead of 16 to 18. And that's another thing, arsenic's a strong carcinogen. And there's a strong correlation from eating chicken at fast food places and cancer. You have anything else?
I just wanted, I'm still looking for what am I going to go buy to put in my yard? I want you to tell me.
Nature's way on 1488.
Thank you. Yes, ma'am.
I'd like to make my own compost, but I'm having a hard time. Do you know the good resources like that? Where to go to find out how to make compost?
On my website, I have a file called Sources of Information. You go to the one, there lists 4 or 5 books on backyard compost.
And your website is?
natureswayresources.com.
Okay, thank you.
Nature's Way
Now,
Resources.
10 more minutes.
Oh.
If you have something you want to cover.
Oh, yeah.
And then let's wait, hold till the end for any more questions.
Yeah.
That work?
Again, erosion control, this is use the blue-green stuff. This is the north slope, use compost. Both pictures 3 months after application. Which one did a better job stopping erosion? Which one got the government bid? This is at a landfill near Central Texas. Every 6 months, they go out there, taxpayer dollars, and redo it, regrade it, rehydroseed it. Been doing it for 30 years. Rather, because compost made the project 10% more expensive, but it stopped the erosion. So I can go on and on, but I want to talk about nutrition. A little bit under soil science, when the soil's acidic, we get more elements released. What we're learning is that if we got microbes in the soil, the pH of the soil is not as critical as we used to think. This is one at my house. I live down in Sugar Land, black gumbo clay, pH 9 to 10, depending on where I test it, very alkaline. And all my textbooks said citrus likes a sandy loam, slightly acidic soil. Put a kumquat in, came chlorotic, just like my book said. It was putting on fruit, putting all its energy in fruit, it knew it was dying. I came in for a wheelbarrow load of compost, put it in, the fruit had dropped. This was a few months later. All the chlorotic problems pulled up. The only problem was the tree started growing, got 15 foot tall, blocking the bedroom window. My wife made me get a chainsaw and cut it down. And before Uri, I had about 18 varieties of fruit trees and citrus in my yard, all growing in that black clay. It wasn't the pH they cared about, it was the microbes in the soil. Another example, I read an article in one of my soil science journals about hydrangeas, typically acidic sandy loam soil. And this guy said he was growing over in Scotland, University of Edinburgh, growing hydrangeas in a pH 10 soil. You know, that Austin's chalk cliffs and stuff they got over that part of the world. So I put 4 dwarf hydrangeas in, became chlorotic. Dying, put compost around one. The one with the compost healed up, and the one with the compost had one on both sides walk. Broke the genetic dwarfing, became so big I'm out there with my machete pruning it in the spring. Finally had to rip them out, they were growing so vigorously. But in the same alkaline soil. But the purpose of the research, it was not that hydrangeas needed the acidity, they were hyperaccumulators of the element magnesium. So when was magnesium available? Either when you had lights and microbes that could go get the magnesium atoms, or when you had acidic conditions, it became water soluble. Okay, a couple other quick ones. Tree root density under grass. Trees would like, remember, 100,000 has more fungus, grass wants more bacteria. Tree root density under a native mulch. Again, drought, flood, production, which one's going to be better? So we pair the mulch with the type plant we're growing, we can get better results. Again, this is fungal-based compost. This is peat moss here, rose, same species of roses across. Cuttings, about 80% rooting success here, right at 100% on the organic side. Had mildew and black spot on the peat moss conventional side, 100% disease control on the organic side, just by changing the soil. Turf grass. Another example, this is a football for Christian High School on the west side of Houston a few years ago. The landscape customer of mine told the people there, he said, you need to put compost down. They had overseeded it with rye, they put fertilizers, fish emulsion out, everything. Nothing was working. So he came out and got 1 yard of compost, put it in that 50-yard line, made that big circle, spread that 1 yard out, you know, it's like 1/8 of an inch. On January 15th, pictures taken February 1st. Beforehand, the grounds people said, oh, compost is too expensive, it doesn't work. And all of a sudden, where'd you get it? How fast can you do the rest of the field? They came into the rest of the field by the middle of February, it all greened up. But the side effect that year, besides having mow more, there was about an 80% reduction in injuries for the football players. Pulled bones, shin splints, muscle pulls. As you saw here, how the microbes took that clay, made it soft.
Yeah.
Made the soil give. So instead of getting injuries, the medical savings pay for the compost 100 times over. Okay, wrapping it up. We hear a lot about NPK, maybe about calcium, magnesium. We don't hear a lot about micronutrients. There's 79 elements in the human body. And the same from our university, you can go plant on 16 elements. You see kind of something wrong with that? If the plants are mining it out of the soil in our food, if you don't put it back, what's happening? My first exposure about 30 years ago, I was planting a vegetable garden out behind my house. This soil had compost in it, mulch, been well organic for years. I was planting broccoli, Brussels sprouts, cauliflower, other members of the cole family. Every other transplant hole, I put in a little teaspoon of mineral dust, basalt dust product. Nothing had a response except the Brussels sprouts. But boy, did they have a response. When it got into May, these died. These were producing good Brussels sprouts in June at 95-degree temperatures. The suckers wouldn't die, so I could plant my purple hills. The bottom line is we don't know what plants need. So we try to get, there's 84 naturally occurring elements. There's 79 in the human body. So we got to get them in the soil. People know you're supposed to take vitamins, right? So let's take vitamin B12 as an example. Anybody know what element B12 is built around? Cobalt. So if there's cobalt in the soil, say we had 50 parts per billion cobalt in the soil, the microbes would make a molecule B12, the corn, peas, spinach would absorb it. What happens after 50 years if you never put it back? Well, is B12 important? It regulates our immune system. Since 90% of Americans are deficient in B12, we wonder why COVID hit the population so hard. So, Anybody ever heard of a disease called pica?
Yeah.
I remember
Were
when
you
I was,
wanting to eat dirt?
yes, I remember when I was in college up at Stephen Boston, Nacogdoches, I'd go up there and I'd see poor families eating clay off the side of the roads. That's to get the elements they're craving. In horses, we call it priving. But some things that due to a lack of calcium, osteoporosis, kidney stones, Bell's palsy, receding gums, arthritis, bone, heel spurs, cramp, twitching, PMS, and lower back pain. 147 diseases associated with a lack of calcium in our diet. Lack of copper, aneurysms, gray hair, skin wrinkles, varicose veins, sagging tissue, usually elastic fibers. You know, my first experience, like I said, I'm chemical sensitive. I was at a funeral many years ago. Ladies' perfume was making me sick. By the way, secondhand perfume kills over 6,000 people in the United States every year. Anyway, I was at a funeral, didn't want to walk out. Time I so I went to the back parking lot, went into convulsions, ruptured my disc in my back. Intense pain, you know, God, please take me. 3 different, my GP and 2 other specialists, all want to do surgery, fuse my vertebrae, never do sports, never garden again, $85,000 surgery then. I didn't like that idea, but I called up a guy that I'd met years ago named Dr. Joel Wallach. He was an MD, started off as soil guy and veterinarian and MD, the link between soil and health, a lecture I went to. So I called him up. He had retired. He said, you don't need surgery. You've got a copper deficiency. Take chloral minerals. Okay, what's that? Anyway, then about 30 minutes later, the guy does my insurance, my business. He just had quadruple bypass about 4 weeks earlier. I said, hey, Rich, what'd you do this weekend? Oh, I rode my bicycle to San Antonio. You're 4 weeks out of quadruple bypass and you did a 200-mile bike ride? Yeah, doctor put me on chloral minerals. I feel better than I had in 30 years. I said, okay, Lord, that's twice pretty good, Rich. I started taking it. In about 10 days, 2 weeks, my pain level started dropping. About 30 days, I could touch my toes. 6 months later, I did 1,400 pounds. And even today, in my Smiths, full flexibility in my back. $70 worth of minerals versus 85,000 surgery do nothing. So anyway, a few others. Then selenium, heart attacks, white muscle disease, liver spots, age spots. You have lack of bismuth, you get ulcers. If you don't have boron, you can't absorb calcium. It's used to making the estrogen menopause. Aluminum. If you don't have yttrium, rare earth element in the diet, where a gene attaches to the DNA helix, there's a yttrium atom. If you don't have yttrium, the body will use aluminum. It's a different size, shape atom. Causes a misalignment. You have a genetic mutation due to diet. So, vitamin D is important for our immune system. So if you don't have that, the element scandium, vitamin D can't work. But if you want to, the doctor that I did called Joel Wallach has famous lectures out on YouTube called Dead Doctors Don't Lie. And it's all about how the trace elements help our health. So
He has a book named that too.
yes, he's got several books and many papers. So anyway, now we have a product where we mix green sand with salt sand, green sand, and all together, so we get these trace elements, cheap insurance for your plants. Adding trace element to our soils does a lot of benefits. And this is illegal in about 20 some states because it rots the bark. You have volcano mulching. 23 states made it illegal. And here are some great books. If you haven't read Teeming of Microbes, it's all about what I've been talking about. Soil biology and how it works. Then the teeming of fungi was the second one. And Jeff will have teeming of bacteria coming out in this fall. It goes into more detail about how these microbes work to make our plants healthy. And it's the soil and the microbes that starts the plants, that feed our insects, that feed our birds, that feed our animals. So everything dealing with being natural starts with the soil. There's the book I co-authored. Dr. Randall has about growing food and vegetables. He ran our urban harvest, our community garden. That's 30 years experience at several hundred locations around. We got a lot of stuff paper from our website. We published a free gardening newsletter. When the Chronicle got rid of their garden writers about 6-7 years ago, I hired Brenda Smith, the lazy gardener. She writes a free electronic newsletter every week for us. It's available on my website. If you want to learn more about minerals, there's an organization called remineralize.org. Probably one of the hottest topics worldwide is remineralizing the soils, because that's the first step in correcting so many problems. So questions? I hit you up a lot in a short time. Yes, ma'am.
CoCoRaHS, is that how you say it?
Mycorrhizae.
CoCoRaHS, for ants, fire ants. Does it come in a powder? Do you put it on the mound?
It comes usually in a powder in a spore form, has some kind of carrier form.
And you put it right on the mound? Okay,
Not on for ants. This is for make trees and plants grow better.
right. But I've got a community garden on the edge of the forest and we've got a fire ant.
Yeah, they make some nematodes that are very good for attacking fire ants. They eat the eggs.
Yeah.
Yeah, and the mycorrhizal fungus, not the fungus that hurts fire ants. There's like, a tablespoon of whole soil may have 3,000 species of fungus. So which one it is, well, don't know. There's been no research, but that pattern has been noticed.
Okay.
I remember, 20 years ago, down in Houston, there's some people took an area that was about 75 feet by 150. They put bark mulch on it, it was out in the sun, and they put native mulch on it. 2 years later, there was something like 40 ant beds in the bark mulch, one ant bed on the edge of the native mulch. Because it fed the microbes that parasitize fire ants. Is it perfect? No. If you take a problem here and you shrink it, then it makes it easy to use a bait or something else to control it. Other questions? Yes?
What is the name of that compound you just talked about with the fire ants?
Nematodes. It's an animal, it's a microscopic worm. And actually there was some research at Sam Houston where they were actually identifying which strains of nematodes work best a few years ago. And I haven't kept up with it. But anyway, many nematodes, like I remember my kids were here, I had a dog, we had a flea problem, I got rid of the fleas out in the yard. So, yes, ma'am.
I have compost,
Uh-huh.
big compost that I do all the time. I'm always adding to it everything. But how do I add the minerals, like all the minerals, or does that come with all the compost? It's
No,
just
that-
part of it.
Well, plants grown on mineral deficient soil are not going to be in the feedstock.
I don't understand what this says. Sorry.
If plants are grown on soils without minerals, there will not be minerals in your grass and leaves. But how you
No,
add
I have a compost that I use,
it, okay. But
but
if
I'm
the,
just saying, like, you're saying it needs minerals, but where do I get those minerals? Like,
once I said, we blend the granite sand, basalt sand, green sand together, it has all 79 elements.
Is decomposed granite a good source of minerals?
It is, but it's only a partial source. That's why we blend all three together to get all 79.
Okay.
That way, 40-pound bag covers 300 square feet, did it once every 5 years. Granite sand, basalt sand, and green sand. Green sand's been in the horticultural text for decades, been beneficial. It used to come only from New Jersey, it was too expensive. Then we found some deposits here in Texas, one outside of Cleveland, another one outside of Blanco. So, Brady. So it's become cheap now.
I'm afraid that's all the time we have. And thank you.
Certainly.
And y'all have the privilege of, John had told Scott that he's retiring after this year. And so this may be our last soil talk that we get, and y'all got to see the man. So anyway, thank you very much.
1488?
Yeah.
1488, Nature's Way Resources.
On the east side of 45.
Thank you very much. Okay, and if y'all need it turns out that we're time limited on the rooms. And so we're gonna just press on. If you need to take a break, just go on out and then come back in. I would like to introduce Ashley Morgan-Olvera with Texas Invasive. She's been there 10 years and now she's their new director. And she's at Sam down the street, and this is her first time to yes, and so she's going to talk to us about invasive.
I'll try to talk as fast as I can.
Yeah.
Because my time kind of is like cut in half. But please write down texasinvasives.org or tsusinvasives.org. Those are websites that you can go to learn. It should be the only PowerPoint right up there. Yes. Those are the websites you can go to read more about the invasive species that I'll be introducing to you. So part of the time I might be standing, I might be sitting. I have one obvious condition, but I also have two torn meniscus in one knee, so I'm not very good at standing for a long period. Well, Now it's only 45 minutes, but I'll be up and down, hopefully, so keep y'all engaged. So as she mentioned, I'm actually Morgan-Olvera. I've been with Texas Invasive Species Institute for 10 years. I was their education and outreach coordinator, field technician, what have you. Now I oversee the whole program, which has merged with TexasInvasives.org. So we are the same thing now. I turned it off, I turned it back on. There we go. We focus on not only early detection and rapid response of invasive species, but also public education. Because the more people that are aware, what is an invasive species? How am I contributing to its spread? The more that we can do on a local level, which really helps us out with the research as well. So again, TexasInvasives.org or TSUSinvasives.org are invasive species websites that you can go to learn more about invasive species, their management, how they got here. And this has all been a great funding source over the past. Texas Invasives was founded, 11 years ago, and we were just a couple years behind them. We were always sister entities, and that's been brought together because of Parks and Wildlife, USDA APHIS, which is the Invasive Species Division of the USDA, A&M Forest Service, Sam Houston State University. And as she mentioned, yeah, we are housed just right down the road. So we are now, Texas Invasives was in Austin, now everything is found here in Huntsville. So I always start at the beginning because there can be a lot of misleading terms out there. You might hear the term exotic or weed. An invasive species has its own definition. Mind you, it's only been a federal definition for the past 23 years. So think about that when I start going into when species arrived here. So in 1999, there was a federal decree naming what an invasive species was. And it is a species that is non-native to the ecosystem under consideration, who causes or is likely to cause economic, environmental, or harm to human health. Right, so it causes harm. Harm can come in many different flavors. It can affect many different aspects of not only our ecological stability, but our economic stability, and then our own human health. So it can impact forestry, agriculture, industry, human health, recreation, and that's why we have to combat invasive species. That's why a definition was finally given, so then you could stop the, the importation of certain things. So the economic impact of invasive species in the United States alone is about $138 billion a year. That's to manage, remove, slightly make a dent in things, right? It's a really hard fought battle. And so the more that we do to prevent it on our local level, the more we can educate the public, we can make that cost be less every year. So human health threats, social and recreational, you've got where it can impact your boating, but it also can transmit disease. This is an old Texas Parks and Wildlife campaign, but it's still effective. You might have seen the billboards. This is representing what giant salvinia is doing to a lake, an invasive aquatic fern. It's not only covering the lake so that the father and son can't fish there, but think about everything else that's underneath those ferns. Those ferns are taking up all the nutrients, all the sunlight. What about the fish under there? What about the aquatic plants, the invertebrates that are under there that also require sunlight, oxygen, certain things that giant salvinia is now smothering. So this has an ecological, economic, and recreational impact. Oftentimes invasive species can impact many facets, but are they causing harm? Emerald ash borer is one of our more infamous beetles, and we'll talk a little bit more on how to identify it later. This is the same street in Ohio, planted with ashes. 3 years later, once the emerald ash borer came through, it's decimated the ash trees. Now, there are native bark beetle species. The problem with invasive species, they cause much more harm. Our native bark beetles have more of a symbiotic relationship. Oh, okay, this tree's already struggling with drought. I'm gonna kill it off now, right? Usually our trees have to be stressed to have bark beetle problems, whether it's drought or maybe there's some sort of soil imbalance, right? They're not getting all the nutrients they need. Invasive species will attack healthy, young, doesn't matter. They will attack it and they will kill it every time. So the fire ant, one of our another infamous invasive species, this is one
Quick
that,
question.
yes,
Can you stay till 12:30?
I sure can.
I just extended our time.
Ooh, I'll talk a little bit slower, because I was kind of prepared for a little bit over, and so I was like, oh, okay. So the red imported fire ant, this is another invasive species that attacks. It affects many different facets, right? It has the ecological impact where it attacks native ground-dwelling animals like whales, horned lizards. It harms our soil arthropod community, displaces native ants. It has a big ecological impact because they will destroy crops. They'll eat your corn, your blueberries, your cabbage, and fire ants alone cost the state of Texas $500 million a year.
I'm not versed in fire ants. Is there another kind of, is there more than one kind of fire ant, or is that just the kind of fire ant?
There is also the black imported fire ant. So there are several Solenopsis species. Ants are super diverse, but this is the main one that we encounter. Yes. This is, when people say fire ant, they're usually referring to this. The black imported fire ant is not very well established in Texas, and it's not as aggressive either. I think red and angry, because it really is. And then it also can kill you, right? If you are allergic to fire ants, if your animal is allergic to fire ants and you were bit by too many, right? So this ant alone can cause a lot of harm in many different ways. So I spent the first few minutes talking a lot about harm. And if an invasive species was only to cause harm, right? Say it came and you could easily trap it and remove it, then maybe we wouldn't be talking about invasive species. But not only do they cause harm, they quickly spread. Whether it's they make more babies, they have shorter generations, they produce more seeds, the birds like their seeds more. Whatever it is, they spread and grow faster than our native species as well. Maybe they're just sometimes they're generalists, right? Doesn't matter what kind of soil they're in. Doesn't matter what kind of food source is around, they'll figure it out. Perfect example of this is the lionfish. So the red lionfish is an invasive species. It's a very problematic invasive species. However, you can still buy it and have it in your aquarium. So please note that just because something is invasive doesn't always mean that it's federally regulated or even regulated at the state level. Now, there are plants and animals that are illegal to sell. Red lionfish is not one of them, so it's really up to us to be responsible pet owners because the pet industry is a major contributor to invasive species as well. So the lionfish was in an aquarium in Miami. I mean, yeah, that makes sense. We have aquariums all throughout here. There's usually a lionfish. Well, they had a hurricane in 1985 that happens. It's Florida. A pair of lionfish got out into the ocean. Nothing about it. We're talking about 1985. That's 15 years before there was even a federal definition of invasive species. So not everybody's thinking about the problem here. Oh, okay, I guess they were released to a new wild. What can you do? So the first 12 years, there wasn't a huge notice of growth and spread. It seemed to be isolated. Well, then you look over the next 23 years, and the red lionfish has completely invaded all the way up from Philadelphia down to Venezuela. That's because it has paraplegic venom in its spines. So it doesn't have a lot of natural predators here. This fish is in Southeast Asia. In Southeast Asia, in those Pacific waters, there are plenty of predators that can keep the lionfish in check. However, we may have groupers, we may have larger animals that can definitely eat a lionfish. Will they survive?
Which stuff do you want?
I mean, we're talking about paraplegic venom. So it's going around and it's eating anything it wants to. We actually did a study looking at parasites of lionfish, and we found out that they were pretty clean, which is almost a bad sign. That means they're not really susceptible to infection. But not only were the lionfish clean, they were really fat. Their livers were fatty. Their stomachs were huge. They were huge. So these lionfish are really gluttonous. They have no predators. They're going around eating whatever they want to. And they're having a lot of indirect impact as well. They're eating the fish that maintain coral reefs. So then that causes our coral reefs to get covered in algae and things that are normally removed off of them, and it's causing death to our coral reefs. So not only is it having a direct impact.
I'm still in my class, baby.
Populations, but it's having an indirect impact and a much deeper impact harming our coral reefs. And this was all just from a single pair of lionfish getting out.
These
And
are all
they-
options. These are basically the same
They
thing.
eat a lot.
This one's less full than this one. Right, use the less full one.
It's still a very big problem. Us humans eating the life. A lot of them
I'm listening.
Yeah, you just get you cut off the spines and the meat stuff. It's not like a puffer fish where you have to be really, really precise in cutting it, but she's exactly right. That's even a large campaign that's that's trying to keep momentum in Florida, is incentive to remove them, because it is a delicious fish when cooked, and it's up to us, right? We're the reason fish were even brought to an aquarium, humans were, right? So we have to be the apex predator. We have to correct these balances. And so, yeah, there's a lot of eat the fish.
Flamethrower?
It's kind of hard to keep everybody in that momentum, but I love those kinds of outreach campaigns because it can be effective. We can make a difference. So oftentimes species spread for different reasons, right? You call in your pants, the birds can carry them tens of miles. The adult insect can fly 13 miles itself, right? There's a lot of ways they can disperse, but we can't always explain expansion. And I kind of hit on it when I was talking about the lionfish. Most of the times, the reason we can't explain why a species got where it was, like the fire ants, like the zebra mussels, like lionfish, it's because of human assistance. For a long time, it was accidental. I mean, globalization has been going on for easily, 200 years now? That's a lot of stuff moving back and forth. Just like we like to bring in tropical plants, that's a lot of ways that things have been introduced. So produce, nursery stocks. This is why customs exists, right? It's not just to control what you're bringing back, but it's also looking at all sorts of shipments coming in, because we weren't looking for those things as easily as 30 years ago. And now we're dealing with the impacts of it. So a lot of bark beetles have come in on wood pallets. A lot of ants and other microbes have come in the soil of plants. Zebra mussels were introduced in the ballast water, right? Cargo ships, they pull up water. When they leave port, when they enter port, they release that water. I mean, it's not like there's UV filters cleaning out ballast water. Ballast water is just there to keep the boat balanced. So that's exactly how zebra mussels got introduced to the Great Lakes and are now a big problem. There's also intentional introduction. Sometimes, so the landscaping industry, this is where you're going to find most of your contradictions. You're going to be like, well, Ashley talked about this species, but how come it's so readily available? Or how come people are so resistant to remove it, don't they know it's an invasive species? How come I can still buy it in the store? Again, just because something is invasive doesn't mean that it's prohibited. So it's really up to you to make good choices when you're bringing in new plants. And then biocontrols. So there's now a lot more research that goes into them. Before you introduce something to fix something else, they do more research. That's because there were mistakes made, right? So we're already trying to correct like 200 years of mistakes, of moving things back and forth willy-nilly. But sometimes we're like, okay, this was invasive here. Why don't we bring a predator from there over, control the problem? That's also what was happening in like the 70s, 80s, 90s. We're learning from our mistakes. Things like the cane toad were brought to Australia to control something else. The cane toad is native to Central America. As you can see, it can get quite large. And it's that hallucinogenic toad. So it's the toad that secretes chemicals that causes hallucinations. So there's only so many predators that can survive eating it, right? And so they brought it to Australia to control something else. Now they have to have cane toad hunts because they are overrunning everything. They're eating, and Australia is such a unique place with all of its animals. They're really destroying their biodiversity. So that's why sometimes you might hear researchers or other people talk about, oh, they're looking at a biocontrol to release. Now we take 5 to 10 years before we make those big jumps, because we've got to make sure, are we making it worse or better? So researchers are just half of it. Researchers, the education campaign, the USDA workers out there trying to mitigate all the efforts. And the other half of the pictures is just engaged and informed citizens, helping make better choices, maybe even removing invasives from your area in a local setting. So what can you do? These are the 2 websites I mentioned at the very beginning. I'm gonna sit down now. Oh. So these invasive species databases have illustrated descriptions, distribution, and habitat. So again, I'm going to go over quite a few invasive species. You can always just write them down and go back to our website for plenty of information. So we go over biology and spread, history of introduction, and ways to manage or control them. We also have a monthly newsletter you can sign up for at our website. It's called an iWire. It talks about invasive species issues happening in the nation, maybe programs that are going on in Texas, or things that other citizen scientist groups within the state are helping with. So, and it also will provide workshop schedules that we can host or that we're hosting across the state. How do we stop a species from spreading? We've got to prevent dispersal. Stop giving them a free ride. Think about what you're bringing into your own area, right? And then also controlling what is in your area properly. So that's why programs like Don't Move Firewood exist. Bark beetles, invasive bark beetles have been their spread is directly related to people moving firewood. It may sound simple. It may even sound silly to you, but at one presentation just a few months ago, someone said, oh, well, I chopped down my neighbor's tree that died of beetles. I brought the firewood over. Now my trees are dying of beetles. I'm like, that's exactly why. You don't always know what's in that firewood, but now after this, you could at least look for, is there beetle infested wood? It's really not worth bringing over to your area, but that's how they catch free rides. Zebra mussels, giant salvinia, directly related to dirty boats. You know, you didn't think about these things. And unfortunately, that's helped these invasive species spread. And it's now a state law. You have to clean, drain, and dry your boat. You have to rinse off your boat when you leave one lake before you go to another, because just one piece of salvinia, just one small piece of a zebra mussel adult or larval, that's all it takes for them to take over, because they're really good at spreading. That's why we have educational programs. So we have the Invaders of Texas. We help Parks and Wildlife post things about public awareness, so never dumping your tank, right, to help prevent the establishment and continuation of irresponsible pet owners. So there's a lot of trapping and monitoring that we're doing on our end, but we always need help with vigilance, right? I'm only one set of eyes. In this room, we're now easily 20 sets of eyes, and that helps. Just anybody that's being engaged, looking out for certain things. And so with TexasInvasives.org, they kind of developed a Sentinel Pest Network. This is basically a subset of invasive species that we really want your help looking for and reporting, so that we have an idea of where they are and where they're going. Yes, ma'am.
This is gonna sound really left field, but on the very first slide, you had a picture of a slug that was black, and I think it was taken in my backyard, because I think you come to my house and picked up 2 of those.
I thought you were familiar.
Okay, I was like, wait, I think this is from I was like, I think that's a picture.
We're definitely gonna talk about that guy.
Okay, cool.
Good to see you. I was like, man, she looked familiar, but I have mush brain at the same time, so I'm like, I don't know. So the Sentinel Pest Network, again, it's a subset of invasive species. So our databases cover hundreds of plants and pests and diseases that are out there that need to be aware of and discussed, but these are ones that we're really concerned about them spreading throughout the state, and we want your help reporting them through our website. So the Sentinel Pest Network, again, you've got our websites that you can always go to. Texas Invasives has a website and a phone app, and you can always go to the Quiet Invasion. galbayinvasives.org has a really great online resource as well. We may not be exactly in the Galveston Bay watershed, at least in the woodlands, you're kind of closer to it, but the species they have there are found somewhat statewide. Like they're main big issues that you can look at. So there's plenty of identification resources to help you once I get through this. So this is now the list of species that are on our Sentinel Pest Network with Texas Invasives. And now that we've merged programs, we're hoping to add other species on here just so that people can report them easier. And I'll show you all how to do that later. But the list is expanded from 12 to now 26. It's got things like the apple snail, Congan grass, tropical soda apple, crazy tawny ant, African land snail, lanternfly, Cyrex wood wasp, Japanese climbing fern. So there's a lot of plants on there, but also it's basically half plants, half insects, and then there are some non-insect animals listed. And again, these are species that we're encouraging you to just look out for and report. Don't worry, we're not going to go over that many species, but we are going to go over a few that you can easily encounter in your area. The first one, yes, ma'am.
I'm just curious, like, if we report them, then what do you do with that information?
So, and that's a great question. So we have ties with Parks and Wildlife and the USDA and the USGS, they're non-indigenous species. We report to them, so then there's an understanding of distribution. We can then provide you things that you can do on your level, but we can't exactly implement a team to go out and remove it, but we're keeping track of, because Parks and Wildlife wants to know, where are these? How quickly is it spreading? Are our education campaigns working, right? So we help spread that information and get it out there to the federal entities.
By Land Conservancy, we do realize invasive species, but we can certainly use help. And maybe it's a resource to report it so that you could at least.
Yeah, be aware, or maybe we can assist with a work day or something. Yeah. That's great work too. So the giant salvinia, this is one we're briefly talking about. It's been used a lot in educational campaigns because it is really destructive for just being, oh, it's just a plant. Well, it's a plant that completely smothers its habitats. It was intentionally introduced as an aquarium and aquatic fern, and then it was unintentionally introduced because it was a contaminant in aquatic plant shipments. So just like you might have heard of seed contaminants, contaminants have been happening for a long time, and that's attributed to the spread of invasive plants. So you can see that giant salvinia is really well established in the eastern half of Texas now. It was first found in South Carolina, kind of out, it was expected in aquariums, right? But it wasn't expected out in nature. So it was first detected as naturalized in South Carolina in 1995, and it's quickly spread throughout the southeastern United States and then separately over into California. Thankfully, it is actually quite unique looking in the fact that we don't have free-floating aquatic ferns that are native to our waters. A free-floating aquatic fern means that it's not rooted to the ground, it's floating on the surface. Being a fern, it actually has, so it normally has two leaves that are on the top surface and then a root-like structure that is underwater. So it also is easily, here you might think, oh, those leaves look kind of blurry or fuzzy or maybe like Velcro. That's actually the leaf hairs that are on them, which you can see with your eyes. And if it looks like an egg beater, that means that you have giant salvinia. If it looks more open-ended, that actually means you have common salvinia, which is also an invasive species. So either way, it's an invasive salvinia, and we would really like you to report it to us. There has been progress on a biocontrol for this. Parks and Wildlife has done a lot of research, like 10 years worth of research. to ensure that this Salvinia weevil, it does exactly what it should do. It exists for as long as there is Salvinia there. Once the Salvinia is gone, the weevil's like, okay, I've led my life, and it dies as well. That's exactly what we want. We're releasing something to control something specifically, and then everything, you know, the weevil doesn't move on to other aquatic plants or anything like that. So there has been successful biocontrols. Parks and Wildlife is coordinating where they're going to be a more availability to the public. Ideally, you can contact them and they will ship you weevils for you to release in your area as well. And then there's always the clean, drain, dry aspect of it, that please, if you're boating, to just make sure that your equipment is clean. There are invasive snails on our Sentinel pest list. And I do have, I know y'all are kind of spread out, but I've got some things that y'all can start spreading around while I talk about them, so you can kind of see what I'm thinking of. Of course, I have this finely packed, so I have to, there we go. Thank you, that's the first one. And then I'll actually,
So go ahead and start this one.
yeah, actually go ahead and start that, and that, and that. I mean, just,
Okay.
yeah, all that if you could. You got it. Thank you. So the first thing she's passing around are some of our invasive mollusks. I dropped the clicker. There we go. So there are two invasive snails to be concerned about. There is a significant difference between them, mainly the size and shape of their shells. So you'll see some specimens being passed around. Even the example of the African land snail can get much larger than that, but you'll see the apple snail example, it's about the size of your hand. Like it can be about a, you know, it's a baseball size softball. Yes, there has been some observations that they are, limpkins are eating that, and then I want to say there were some kites possibly in South Texas. So aquatic birds are, and predatory birds, they are adapting to eat these, but we don't want these around for, we'll get to.
Pink eggs around the water. On the water or?
We'll get into that.
Okay.
Yes, ma'am. Okay, so the first one is the giant African land snail. Land snail is it's a terrestrial snail. This slug is constantly intercepted by USDA aphids because people are like, oh my gosh, what a cool pet. No. So I'm traditionally a parasitologist. That means I study parasites. Slugs, snails, notorious for spreading harmful parasites. We will talk about that. This species certainly does it. It has cost the state of Florida almost $40 million and 2 10-year periods to eradicate this species. And then I've even met people from the Bahamas where if you have this snail in your house, like their version of the CDC comes through, has to sterilize everything because they are so great at spreading harmful parasites. So please, no, never a cool pet. Tell your kids, your grandkids, your cousins, their kids, they are not good pets. Anyways, this species is federally prohibited. That is why Customs is like, no, you cannot bring this enormous snail into here because we already know that it is a large threat. The apple snail, now this one is established in Texas. It's an aquatic snail. So the adults are fully aquatic. They live underwater, murky waters. They're in the bayous of the woodlands and all of that. And we really need your help documenting and reporting their spread. The easiest way to identify them is going to be the pink eggs that they lay around the water. So that is so what she was asking was a great question. The adults are fully aquatic. It's hard to see them sometimes, much less catch them, squish them. They're really, I mean, you'll see that they're big guys. So they're not exactly something you want to go. But if you see pink eggs, please report that. I think that means you have apple snails. We don't have any native snails that are laying large pink bubblegum-like eggs.
How large a cluster is that?
Couple of inches. I mean, they could easily lay like, I mean, if you've seen this.
I've seen it 3 weeks ago and it came
Not surprised.
New docks.
Not surprised, it just got to that area of Lake Houston like last year or something in the.
And I asked my friend, what the heck is that? And she didn't know.
The apple snail eggs, and so what we highly recommend is to squish them when you see them. So get a pole or something to scrape and, yeah, just stop that generation where you can.
If you,
So, yes.
if you scrape them, is that enough, or you have to like actually step on them?
I mean, if you can step on them, but depending on what you're using, I mean, not to be, they get really oozy and mint. So if it looks like really nice and bushed and oozy, you probably did a good job on that. And you don't want to necessarily just knock them into the water, because if they're mature enough, they will just go ahead and turn into adults in the water.
What's the damage they cause besides spreading parasites?
So they also outcompete our native snails. They eat aquatic vegetation. They disrupt the ecological food webs in aquatic situations to where the water gets too clean sometimes, where it can harm the other species.
How long, like, is there, do they lay eggs year round? Or is there like a time of
Around
year?
here, they easily could, because we have more mild winters. They easily could, but you're going to see this being a lot more prominent now through October or November. That's why I'm like, there's only probably a few months you might not see eggs, so it's practically year round. And so another one that was being passed around, this is a native species. I often get a lot of people that are reporting this species when they think they're seeing the giant African land snail. So I hope you can notice the differences. Now, please report away. If you are concerned, we want a report, because we don't want to have anything ever overlooked. But they are both terrestrial snails. This is one, so the rosy wolf snail, it is native, but it is predatory. So it's kind of up to you, you know, do you have other snails that are providing benefits? Have you noticed that it could easily be eating your earthworm? You know, it's up to you, it's your discretion, it's your yard, right, on if you want to remove this one. But please note that it does always almost have a pink coloration to the shell. The African land snail will always have striping, like you saw on that one being, it was always striped. And it will get much larger. It's just oftentimes, I mean, the rosy wolf snail is no schlump itself. It can get about 3 to 4 inches. So it's just important to know the difference, but we always want you reporting, because again, we wouldn't want to have anything overlooked. We do have educational panels that we've worked with. Parks and I'll put these up here, Parks and Wildlife and the Dallas Zoo, educational, just basically pointing out, if you see these eggs, we would really appreciate it if you squished them. Again, just any sort of impact, because there could easily be anywhere from 100 to 1,000 eggs in that one clump. So at least you're doing something to help prevent them as well. So one of our invasive.
What about the terrestrial snails? Do they also lay egg clumps like that? That you find?
Not in aquatic settings, but thankfully the African land snail is not here in Texas.
Okay.
So, but we do want you reporting, because we want to get rid of that as soon as it's found. We don't want to be like Florida, spending $40 million in 20 years just to have it reintroduced. But that was a great question. And no, they wouldn't be bright pink either. So the African land snails, it's kind of, you know, your more generic whites, orbular eggs. And that's also how slugs have easily spread with the landscaping industry. Their eggs are hidden in mulch and the potted plants and things like that. So that's really contributed to their spread, which we'll talk about other species later. The next one is the Japanese climbing fern. You've probably seen this. Yes, I was. This guy's everywhere, especially in East Texas. It's one of those, if you think about, okay, so it was available in nursery catalogs in 1888. So we're a little bit behind on management and removal. It was naturalized by 1903. This is still a species. It's not, now it is considered invasive. It's considered noxious, but it's not exactly federally prohibited.
So the thing with that too is when you remove it, it's not spores that go everywhere.
Yes,
And
yes.
so if you do remove it, see if you gotta like bag it.
Definitely any invasive vine, you always want to bag it
It's
up.
terrible.
Yeah, because it will cover shrubs, it covers tall trees, it basically creates fuel ladders, because, I mean, and especially in East Texas, you'll see this vine going all the way up 50-foot tall pine trees, which helps allow fire get to the canopies, which is exactly what we don't want.
What's
When-
the safe way to destroy it?
So what she was mentioning is you want to bag up the parts that you're removing, bag them up, put them in a plastic bag, make sure that bag is sealed and throw it away. But then also the vines that are remaining there, we'll get more into management. Really, the cotton tree is my favorite, so we'll get to that later. It's just because it helps localize and focus what you're doing. But it's always really important with invasive plant management. If you're cutting and applying herbicide, you have to apply that within a minute to 3 minutes, because the tree or the vine will start healing itself, start forming a scab, and it won't absorb the herbicide as well. And with invasive species in general, it's a lot of repeat. So this is the nice spore reproducing fawns that she was mentioning. It can be a really fluid looking plant. It's really variable in the way that the leaves are shaped, so that they can be sometimes where they are stalks or lobed, and they can be pubescent with short curved hairs. The vines can be either orange or black, but the fact that it can have such a varied appearance is actually how you can help identify it. We don't have other vines that are so varied in appearance, or that produce these kind of finger-like fronds at the end of them as well. So they can grow up to 90 feet long, and it can be difficult to break. And yeah, wanting to limit exposure of these reproductive fronds is really why you would want to bag up the vines as you go along, so you're not just helping more settle around. Here's a new vine growing, and then this is the perfect example of why they can be so problematic. They're not only girdling or suffocating the tree, but they're also just allowing wildfires to get more out of control, or a prescribed fire.
So you mentioned that if we notify that we've seen it somewhere, not necessarily a team will be able to come and get it. What if we spot it at like a park or some like public space? Who comes and takes it out? I don't think we're allowed to. So it's
No, you're not. So that's where you could notify that city, but that's where it's kind of unfortunate that then it's up to the city to say, do they want to do something like that? Or you could potentially propose to the city, hey, we've got a master naturalist group, we've got a workforce group. Can we come out there and remove these ferns? Can we, and there is an invasive species task force in the woodlands that does that with other species as well. So sometimes you can approach it as a group, or we could help try to bridge that barrier, pose that to where maybe y'all go out and have a removal work day. You may not be able to apply herbicides, but you can at least go out, physically remove what you need to. And who knows, maybe they'll be like, oh yeah, we'll provide a city employee that can spray the herbicide if y'all are gonna spend hours removing this. But that's where it can be hard, is sometimes the city doesn't see the point or the need to spend that money on it. And we don't have those resources to constantly provide that. And certainly not for something as large as the state of Texas. So that's also the downside. No, great questions. That's also the downside of our state, is it's so large and so diverse. It's really hard to get everyone kind of involved. It's really hard. We can only do so much, but I can talk about them all day, and I can tell you and show you what you can do. So the next thing that's being passed around, we're coming back to one of our more infamous species, the emerald ash borer. I also have some handouts for identification. If y'all want to afterwards, you can always come up here and check that out. So the emerald ash borer is one of our more infamous species because it alone does cost billions and billions of dollars worth of damage. In 30 years, it's killed billions of ash trees of all species. All fraxinus, green ash, white ash, Texas ash, doesn't matter, it will kill it. So It is a bright metallic green beetle, and it is not very large. You'll see it being passed around, but this picture helps give you a size. It's about the size of half a penny. So it's quite small, quite slender, but it's a very metallic green. Another invasive amaryllis that we're concerned about because it attacks soapberry trees. So it is also on our list for reporting. However, we're very concerned about emerald ash borer spreading. It is present here in Texas. It has been reported Texarkana area and in the Fort Worth area as well, and a few counties in between there. So the soapberry borer is black and it has 4 white dots on its elytra. We do have information about these beetles on our website. However, since they are quite small, they're not always super noticeable. It might be the symptoms in your tree that you'll start noticing first. They both cause the same problem in trees. So they're bark beetles. They're feeding on the xylem and phloem. They're breaking up the circulatory system of the tree. So they do cause canopy dieback. So if you have an ash tree or a soapberry tree, if you are noticing canopy dieback, epicormic shoots, so where the tree is trying to re-sprout from the bottom, there's something wrong up top, it'll start shooting epicormic shoots. You might see D-shaped exit holes. Now on the sample that's going around, you'll notice that D-shaped exit hole. It's not like a D-shaped exit hole, right? It's a D-shaped exit hole. So it's quite small. But the D shape is unique to these types of beetles because that's how the adults look when they're coming out of the wood. You'll also notice the bark will start splitting off. There'll be feeding galleries all throughout that. Now again, think about the species that you're looking, like what tree are you looking at? Because there are plenty of bark beetles that do this in other trees, but emerald ash borer is only going to do this to ash trees, which are very prevalent and necessary in the areas that we live in, because we do have riparian areas. Unfortunately, if your tree is infested with bark beetles or emerald ash borer, it's doomed. You need to cut the tree down. You need to finally mulch it. Do not be like, hey neighbor, you want some firewood? No, right? If your tree has died from any kind of bark beetle, you really need to chop it down, mulch it up finally, and that's because you're trying to destroy the larvae and adults in there. I always recommend after you've chopped down the tree, burn it. Be really efficient with what you're doing. Like make sure that you have, the tree is gone, the beetles are dead, it's gone, right? Because again, once it's infested and its bark is falling off, that tree is a goner anyways. And so you don't want to keep the beetles in your yard. You don't want to spread them around. So that's why you either want to mulch the tree. I always just say, chop it down and burn it just to be super efficient. But you can always mulch and spray with pesticide. Yes, ma'am.
Do they infest a pine tree?
Not emerald ash borers, right? But there are a lot of native pine beetles, especially Ips species, that can be problematic in stress trees. But there are invasive pine beetles that we look out for as well. Bark beetles, name a tree, there's a bark beetle for it. Like so those symptoms can be very similar. If you're seeing that, I highly recommend contacting an arborist because sometimes they can do tree injections if you catch it early enough to save the tree, if there's enough of the tree to save at that point. So telling the emerald ash borer apart from other beetles is really the fact that it's bullet shaped, it is bright metallic green, it's got a flattened back, but this red, coppery, purple underside is what's really, really important. There are other native species that we have, right? There are native beetles that are the same genus. We have native amaryllis out there. However, they're not always a bright metallic green. Maybe they've got some other stuff, or they're not on, their host trees that you're seeing this on a hackberry tree. Okay, again, if it's not an ash tree, it's probably not an emerald ash borer, but the one way to be 100% sure is if right underneath their wings, if you've got basically a Christmas bug, green wings, and then a purple-red abdomen, you have an emerald ash borer. especially if it's really close to an ash tree. So there are native species that can cause problems, as I mentioned. It's really about keeping an eye on your tree and then contacting an arborist because they would be the ones that are licensed. There are things called tree injections where basically they inject pesticide into the tree. Doesn't harm your tree, but it kills the beetles that are killing your tree. However, you know, there's a threshold. If you get there too late, that's when you've really just got to chop it down, burn it, and stop the beetle from spreading. So those were ones that we definitely want you to report through our website. These are other plants and pests that you'll easily see in your area that we want you to be aware of and do what you can in your area to remove them. One of them is the air potato vine. So this is a deciduous vine native to tropical Africa, and it's called the air potato because it produces these potato-like tubers that can get, you know, they say up to 8 inches. I've easily seen them softball size. So, you know, a little bit larger than an apple snail, but those tubers can get pretty big. They have heart-shaped leaves, and then the prominent veins always meet at the base throughout it. There are native lookalikes. We do have a native species. So this is Dioscorea volifera. There is Dioscorea villosa. That's more of a native squash. It's not as invasive, right? So it's a vine. I mean, a vine is a vine. If you are having problems with any kind of vine in your area, please manage it, right? It doesn't have to be invasive for you to remove it. However, an air potato will take over much quicker than your native squash vine will. And the easiest way to tell the difference is the native squash will never produce those tubers. So they'll have the heart-shaped leaves, they'll nicely grow, but if you never see these tubers producing, then you probably have the native squash, but just keep an eye on it. Just like your greenbrier or similax, that could kind of look like an air potato, but the leaves are smaller and they have thorns on their vines, while air potato has no thorns. So those are easy way to separate, but please, you know, again, just because it's a native species, it's your area. If you're concerned about those vines suffocating your trees or causing problems, you can always remove them.
Air potatoes sold still?
Air potatoes, now actually, I don't know. So I don't think it's on the noxious list, so it easily could be still sold.
I'm afraid they are.
Yeah, I was like, I never think about people buying vines. I always feel, but yeah. I know that they're not prohibited on a large scale, so it's very possible.
The Woodlands has a big team that goes after air.
Yes, sir, I've got that now. I don't know if y'all can see past my table down here, but yes, there is an invasive species task force associated with the Woodlands Township. Terry MacArthur oversees that. She often has me come out and speak and train the workers to become citizen scientists, not just about air potato, but over other species as well. They do have a large removal program. I think they're also have been releasing air potato weevils. They're part of that pilot program where they're working, the USDA chooses local partners and they're releasing air potato weevils that also seem to be affecting Chinese tallow. So that's a very good thing as well. So there is an invasive species task force out there that can do stuff. This is the slug that she was talking about. So the black velvet leatherleaf slug. The name is long, but it tells you what it looks like. It is black. It is velvety, so it's not slimy looking. It actually looks kind of matte, kind of sleek.
Yeah,
Well, not even
really
sleek,
weird.
right? It looks velvety. Very weird. Yeah, it's one of those, you cannot miss it. We do not have a native slug that looks anything even close to this. It can easily be 4 inches.
Oh yeah, the ones that you got from me were like,
Yeah, when they're on the move, they get 3 to 4 inches, but when they get preserved, they shrink up a
What
little
are
bit.
their hosts?
Hmm?
What are their hosts?
Well, so they're not so much, you can find them in Bermuda grass. They're kind of generalist slugs. They don't specifically attack a lot of plants.
Okay.
They can cause damage in your lawns, just by existing and kind of feeding off of the plants, but we're really just, they're a very good carrier of nematodes. And so it's one of those, like, you don't need it in your yard. It serves absolutely no benefit. So it's one of those, please remove it if you see it, because we have found these nematodes in these slugs in Texas. So nematodes are parasitic worms that usually need other organisms to complete its life cycle. Angiostrongylus species in particular use slugs and rats. However, they will try to infect any mammal that interacts with their life cycle. So that's why I was saying earlier, please do not keep slugs or snails or those things as pets, because we are mammals. We can get infected by these nematodes. However, they are not fatal to us, but they can be prevented. But the thing is that they are here in Texas. Angiostrongylus has been present in Louisiana and Florida and Hawaii for decades. So it's really part of our prevention program now to just be aware. How do you prevent infection? You're like, okay, Ashley, you're telling me that they have worms that can infect me, but it's not that bad. Well, it can be, but they won't kill us. And that brings you any hope. They won't kill us. However, these nematodes, they can go into our brain, they can go into our gut. While they may not kill us, you do not want worm brain or worms in your gut. How do you prevent infection? You're like, oh my gosh, Ashley, you're talking about worms and slugs. Slugs are everywhere. The main thing, the nematodes have to enter your digestive tract. So as long as you're not eating raw slugs, you'll be okay. However, think about children and others that are holding slugs. Those nematodes are in the slime trails. Do you have slugs crawling all over your fruits and vegetables? Just wash your hands before touching your mouth. Wash your fruits and vegetables from your garden if you've noticed slugs. So really, it has to get into our digestive tract. If you hold a slug, know the nematode will not penetrate your skin and suddenly infect you. Because I have a lot of people that are like, oh my God, I touched it. Well, yeah, you touched it, but did you touch your mouth with a dirty hand? Probably not, right? Especially we're in a post-COVID world. Nowadays, wash your hands if you touch something gross, right? Especially before you try to eat. So that's how it's so preventable. You can use you use gloves when you're handling them, but mainly just washing your hands before touching your mouth.
Is there a treatment for this infection?
So the worms will eventually die, but if you can get to, like, they don't finish their life cycle in us, so they will die within us. But yeah, there are antihelmintics that doctors can prescribe. It's just that with these kind of parasites, that may not be their top 10 things. So if you can go in and be like, well, I started having these really bad headaches and blurry vision after I, ate a raw slug, or I was dealing with these slugs and I got stuff in my mouth, then they can guide the doctor. But it's just, in Texas, we're trying to educate that it's out there. So then if you have one of these where it's like, I touched, and again, not every slug is infected, but there are medications to kill them, yes.
So I'm assuming they could probably do the same thing like to your pet.
Yes.
Because I have noticed, we're having all these slugs come up on the porch and they're like all over the dog's food bowl.
Yes, so slugs love dog food, love cat food. It's a great way to bait them. So what I highly recommend is killing any slug that you see. That is the easiest thing. And honestly, Clorox wipes or just spraying down the porch or wherever, those slime trails, the nematodes don't survive very long outside of an organism. So it's one of those, if you're wiping down the area that you've seen them, or Clorox or it's easy to clean up the scene. But yeah, you definitely don't want your dog or cat eating them. What?
The worms, these worms too.
I'm sorry?
The dog, the pet.
Yes. These worms will try to infect any mammal. So they are looking for a rat. However, to them, a mammal is a mammal, and they're going to try the best that they can. So that's why we don't want your dogs or cats eating these slugs, and we want you to remove any that you see, because now not every slug is infected, right? It's just one of those, remove it so you don't have that threat.
I kind of wonder
Heartworm's transmitted by mosquitoes,
Well, yeah,
so
but with heartworm preventative, prevent nematodes also.
not necessarily for these, right?
Okay.
So they do now, if you're doing one of those, like the 3-for-all, those like triflexus or sympatrica trio, those are attacking other pinworms and roundworms. So there's a chance, right? But heartworm prevention alone, that's actually a different kind of worm. But nematodes are pinworms, roundworms, other preventatives that you're giving your dogs, so that would give them a chance. But also just making sure that they're not eating them, and then if you're seeing them, you know, yeah, just kill as many slugs as you can. That's really my take home. But that's something to be noted, is if you have your animals on preventative medication, that could help. So remove any from your property and wash any garden vegetables and fruits. Just as, you know, again, it's not hard. It's not like you have to scald your hands for 30 seconds. Wash your hands, wash your fruits, wash your vegetables, and you'll be fine. It's shown to almost completely prevent.
I was just gonna say, I lived in Spring when you came out those for me. I lived like in Spring in like behind the plaza, like super suburban, urban. And they're really noticeable, at least because I saw like a leopard slug like 2 days later. And they look very different. Like these are like legitimately a matte black. You can't miss them. I don't think that looks like.
And honestly, having studied these slugs for a while, basically any slug that you'd be seeing in your yard, 95% of the time it's going to be invasive. It's either a yellow garden slug, a leopard slug, the black felly. So it's a slug you will easily find on our website. You'll go, oh, it's that one, and you'll want to remove it because they all can transmit these parasites.
And I'm pretty sure Seek identified it for me. And then when I Googled it, I found you.
Yeah.
Like you guys were the first thing that came up when I Googled it.
Yes. So these ones have become quite.
So safe removal would be squishing them and then,
So I mean, you can burn them, yeah. People are like, oh, these are really receptive to fire. Yes, they're soft-bodied organisms. Of course, they're gonna burn. But sorry, but no. So squishing that I always, especially those other slugs, they get quite big. My recommendation is to at least like use gloves or a stick and put them in a sealed container with a little bit of salt. Put as many as you can in there. Throw the sealed container away. If you don't want to use salt, you can freeze them. It is humane on them. They're invertebrates. They just go to sleep if they're put in a freezer, but not everybody wants slugs in their freezer. Great deterrent. Diatomaceous earth is a great deterrent, especially for these flatworms as well. So really these slimy, soft-bodied organisms, they don't like diatomaceous earth because it keeps the top layer nice and desiccated. So it's good for the plants, and then it's beneficial because it's keeping these guys away. So the hammerhead flatworm got a lot of press last year. And people often hear that it secretes neurotoxins and then they think, oh my God, I'm going to die. It's not the same sort of neurotoxin that lionfish have, right? It's a neurotoxin that's used to kill earthworms or to irritate something trying to eat it so that it can get back out and survive. So of the thousands of people that I have known that have reported them, you know, of thousands, let's say 10% of them have handled it, so hundreds of people. Of the hundreds of people that have touched it, I've known like 1 or 2 people that actually had an allergic reaction to it. So really, the threat is not mainly to us with this neurotoxin that they're secreting. It's more that they are predators of earthworms. Our gardens and agricultural settings are already adapted for earthworms. So if you have these hammerhead worms, I know a lot of y'all were talking about compost piles earlier, that's a good thing to keep an eye on. If you're noticing, why are my worms dying? Usually it's this guy, right?
And you would like us to report these?
Yes, you can report these to us. So we do know them to be well throughout your area. So you don't have to report these to us because we've known them to be, but we do want you to remove any that you see. Very similar situation, stick, sealed container, put as many as you can in there, seal it, because these flatworms, just like slugs, they can crawl out of the, you know, If you're throwing it in a trash can, that's not gonna stop it from crawling out, going somewhere else. But these flatworms, you don't wanna cut them up either, because they will regenerate. They're hermaphroditic, they're asexual, right? They don't necessarily need to reproduce. So if you cut them up, they'll grow into new segments eventually. Sometimes you can just spray them with vinegar, they'll dissolve right away, salt, fire, like people said. I'm like, yes, fire would be effective on a squishy thing, usually is. And so we just really want you to remove these and be aware, but always feel free to report to us. Like we won't turn away data ever. Okay, so now we've got, this is the Asian citrus psyllid. It's known to cause citrus greening. And as the name suggests, this is a problem that's happening in our citrus trees. The psyllid was first found in Florida, not in commercial production, but in backyard citrus plants. So the lemon tree you have in your front yard or by your doorstep or whatever, that's where it was first found. And then it spread throughout Florida. And some of us are a little older. We might remember there was a big orange juice problem in like the late 90s, early 2000s. There was a lot of stress on the Florida citrus industry, and that was attributed to citrus greening and this psyllid. Citrus greening is present here in Texas. You might have heard that Montgomery County is in a citrus quarantine, and you might be, why is it in a citrus quarantine? What does this even mean?
Oh, what does the nymph look like? Is it white?
We will get there in the next slide. It's yellow, but it does, we'll get there though. So, so citrus quarantine means that they want us to limit the movement of our citrus because Harris, Montgomery, Fort Bend, and Brazoria counties are already known, 1, to have the insect, 2, to have the citrus greening disease. What is citrus greening disease? It kills citrus trees, ruins fruit production. It's been established in the Rio Grande Valley, which is where our commercial citrus production is, and there are also quarantine areas along the coast. So that's why you may see, maybe, now you might not have noticed it coming up, but next time you come up into Walker County, you'll now see leaving Montgomery County, leaving citrus quarantine zone. And that's just to ensure that we're not moving diseased or infested plants outside of this area and further spreading it along. So this is the nymph down here. It's a yellow, so the psyllid is a hopping insect, one of those phloem feeding insects. It's quite small, but you can see that it would be visible to the eye. However, other symptoms of infestation might help clue you in, where you might see yellow nymphs on there, but you see it's kind of like this plant looks dirty, almost dusty. That's that waxy excretion. So the nymphs have this white waxy excretion as they eat. And so it'll kind of start coating your plants. So it's one of those, if you see this kind of weird, not frass-like, but almost covering on the leaves, you've got an insect that's kind of shaped, psyllids are small, but if it's one of those like, ooh, it looks like it's very proud with its butt in the air, got these adults, got these yellow, it's not looking so good, right? It's looking like you could potentially have.
Will it spread on the fruit or just the plant?
The insects?
Yeah.
So the insects mainly feed on the trees themselves, but the problem is that they are spreading bacteria known as citrus greening to the plant, which in turn destroys the fruit production, and then your tree will eventually die. In about 2 years after contracting citrus greening, it will produce bad fruit and then die.
But it's nothing that goes with the produce that's moved.
So these psyllids, no, they've been more spread from people moving actual citrus plants, but that's a great question. So there are fruit flies and other things that customs looks for in produce. So thankfully the psyllids are not being spread through produce, but they're being spread by the trees moving themselves, which is why there are citrus quarantines being put in place. Did you have a, okay. And so, as I was mentioning, the trees will eventually die. Now, there could be a lot of reasons why your tree is looking infected or affected, right? It could be the soil nutrients. It could be something else. So they do blotchy mottled leaves, the fruit, that's really what's gonna start tipping you off, is the fruit. It's sour, it's misshapen, it's not even fully formed. Unfortunately, that's not gonna, that combined with, you know, are you seeing insects all over your plant? It's not looking so good, and it could be that you have citrus greening. And so we do actually have a program where we can come out and trap, and now I'm running out of time.
Wait, so we are, yeah, so we've got to be,
Out of here
our
by
room ends
12:30.
at 12:30.
Yes.
But then we've got, you know, just time to shut down.
Okay.
Next time I'll do better on reserving the room.
No,
for
it's all right.
time, sorry.
It's all right. So the last few ones that we'll go through, Chinese tallow tree, super common. Can't miss it. Have you seen trees changing colors in the fall? And you're like, I thought Texas didn't have. That's a Chinese tallow tree, okay? It makes up anywhere from 50 to like 90% of the tree canopy in the Houston area. It was imported back by colonists. They thought there would be a huge tallow soap industry. So it has kite-shaped leaves. It produces catkins, lobed fruit that turn into these popcorns. Those shell things will fall off, they'll hurt your feet, very annoying. These are everywhere, please remove them.
How/why were they introduced initially?
Tallow seed soap industry. The colonists thought that would be great. There was a lot of seed oil production. That's how they would make soap. And then also aesthetically, they changed colors. They're pretty trees.
But you didn't mention it, and I'm sure you would have, but the problem with it is they get in the sewer system, clog it up and ruin it.
They completely change pH. They have allelopathic effects on an environment, so they'll completely take over. They can affect the pH of water. I mean, they're very aggressive growers. Those are ones where you have to.
Flush if you have one of those trees.
You have to cut, and treat them. So unfortunately, we're running out of time, but there are jumping worms to be concerned about. Google jumping worm. University of Minnesota has great resources. It's different from your other worms that you're used to. And also, if you're noticing, does your soil suddenly look like coffee grounds instead of soil? That could mean you have a jumping worm. So unfortunately, we're a little out of time, right? But to mainly tell the difference, a jumping worm will have a white collar around its neck. Our normal lumbricoides, our wrigglers, our compost worms, they're going to have a pink color around their neck that is raised. The jumping worm is called that because it thrashes around like an angry snake. Like it's not like I'm irritated and coils up like the lumbricoides will. So that's really something to keep out for. China berry is another one of those trees. Been here for hundreds of years. It was brought over as an ornamentals. This one was brought because it's got pretty flowers, right? Which are actually out right about now. You're gonna see these. Anywhere you see a tallow, you'll see a China berry. They are very aggressive growers as well. They produce way too many seeds and survive for way too long. So as I was talking about, this is gonna be where you're gonna spend a lot of your time retreating. Cutting them down, retreating. Mechanical is not always effective, mechanical alone. Oftentimes you've got to get chemicals involved. If invasive species were easy to get rid of, we wouldn't be talking about it, right? It can take a long time. This is the method I was briefly touching on earlier, cut and treat. This is where you are cutting and then immediately painting on some herbicide. It's great for your larger invasive trees. You could do a combination of this with foliar spray if you're trying to do vines where you cut down at the base of the vine and then you spray. It's just really important that timing. Have one person go through cutting, the next person come through spraying. Because the longer that you wait between your cut and your treat, the easier it's going to grow back. These invasive species will grow back regardless. You know, even if you're really good at it, but it's just bound to be more effective. And then always try to replant because oftentimes invasive plants have lots of seeds down there and they have them well stored and they can germinate for up to 5 years. And this is just a list of, this is everything I talked, look at that, y'all listen to most of that today. Now to our website. So how do you send a picture? Just send a really good picture. That's, you know, this, I don't know what you're telling me. Oh, no, I did that earlier. This is better. That's helpful. Because, you know, okay, here are the berries and the leaves. That can always be helpful if you're wanting to report something. Just, you know, in focus. That's the main take home message. If you're reporting something, especially if you're reporting through our online platform, you can only really send us one photo. So just please make sure it's in focus because we're trying to validate things. So we have to have a certain level of confidence. This is where you can go. Just texasinvasives.org. This right here is how you report to us. No login. Or you can click report it. And then there's a list. No login. You just go right to the website. If you're like, I think this is one of the ones that Ashley was talking about, just give it a shot. Try to report. Find us. And then, so anybody concerned about their citrus, give me an email. I've got cards up here for me as well if you want to grab some. I will come down and take a sample of your citrus tree. I will set up a trap. I will help you figure out, do you have citrus greening? Do you have the Asian citrus psyllid? Please, please, please contact us. We're not that far away. Don't have time for this. But I wanted to end on this so y'all could at least write a few things down. Okay, that's it. We have got 3 minutes to get out of here.
Thank you so much.
No problem.
And you have a sheet to hand out up here.
Oh, I've got emerald, yeah, and then I've got pamphlets on us. So yeah, if y'all want to just take a quick stop up here.
Thank you.
No problem. I got beetle ID and info about Texas invasives in my business card. So. Oh, now, so you can have what is aggressive, that's it for sure, 100%. Now, if it's one of those, like, if it's aggressively growing, sometimes native species can be invasive just the way, you know, if they're really, really successful, then you try to take it back. You know, it's one of those, but it's not an African violet or anything, no.
Release, couple flowers, and the seeds were 15 feet. I don't think you have a choice.
You would definitely want to mow before they're, or try
Yeah.
to get them before they release all those seeds. So at least if you're stopping them before they're releasing seeds, you can try to slow down the growth for the next year. Hopefully then get it more in control. But yeah, sometimes, I mean, some plants,
It's not on your list. It's not on your list.
I mean, it might be. I'm like, it
It's
might be.
annoying.
So there's,
But, you know.
but it could just be a problematic species. But on our website,